Good morning, everyone, again.
Good morning to you.
All right, now it's working. I always try to wait with the YouTube stream so it's not like 10 minutes streaming for nothing. But then you have situations like this. So now it's working. So your keyboard is kind of loud again, James.
Sorry, I didn't realize I was not push to talk. Give me a second.
Okay, so the link to the YouTube stream is in the chat now. And I see that it is different, so I'll put it in the chat description as well, so you can always find it back. Edit channel. There's the new link. All right. Oh, we have someone that's already printing for loops. All right. Good morning, everyone. I hope you're all excited and awake for a new day of Python. It's 32, so I'm already a bit late, and I guess not everyone is here, but it shouldn't stop us from getting started. What we usually do to start easy today is have a little quiz, and in the little quiz we'll discuss things that we learned, or we'll touch upon the things that we learned last week. So that's some kind of way to refresh our knowledge again. In the meantime, I've received an email with a bunch of questions. I'll try to here and there bring that in, but I'll probably also forget it. So if you have any other questions regarding last week's materials, or anything that pops up in your mind now, just type it in the chat or interrupt me and ask it live, let's say. And then we'll make sure that we discuss it as well. So Discord has this nice bot, which you can see on top here as well, if you scroll up a little bit. So all of the questions that we'll have in the quiz here will have some kind of poll, and then you can just easily in the course chat, in the course chat, you'll be able to just click option A, B, or C. The prize for today is Python respect or something like that.
100 internet points.
100 internet points. And now I'm just, yeah. Okay. So if you all ready, if there are no questions for now, I suggest that we can get started. And I need to I need to manage all of these things here as well. I'm going to do it even a bit different. Disclose. There's a lot of tabs open here now, so I'm managing them a bit. We'll get started in a second then.
We only see 3 tabs with the quiz slides.
Yeah, I have 2 screens, so it's like...
Okay, just making sure you're not unintentionally showing us.
Yeah, no, that's okay. Okay. The first question for today is, and I hope it's big enough at least, which input statements are correct? And there are 3 options, and this is the point where I copy paste the options in the chat, and here we go. Oh yes, and also to mention that there's always a possibility of multiple correct answers. And that's looking good. Everyone, or at least almost everyone, is agreeing on B, and now A is popping up as well. So indeed, A and B are correct. It's rather difficult, I guess, to show it here, but in the first case, what we're going to do is just ask something from the user, and we're going to assign it to the variable A without any text in front of that little box that we usually have there, if you still remember it. In the second case, we're going to have a bit of a text in front of it, and that's going to be enter a number. So C is not going to be possible because enter your name with spaces in between is never going to be able to be a variable. So you will get an error there. And this doesn't really say much. Okay. Second question. Which print statements are correct? So A and D for the win. No one is voting for B, and some are voting for C. So this question is a bit of a tricky one, let's say. It's not, I don't think it will be the case that you will do something like this. But anyway, the correct answers are indeed, let's see, A, C, and D. In the first case, so A, C, and D, and I'm going to show you the outputs of them as well. So A was print the string 9 plus string 9. So we're going to concatenate the two strings together. And so we have 99. And that's what's being printed out. In option C, we're creating a string from the number 9. And then we're going to concatenate it to the text 9. So that's also going to give 9, 9. But in number and string format then. And in the fourth case, so D is the sum of 9 and 9, which is 18, and that's going to be printed out. Why not option B? Let's have a look at it again. So that's the case where you're trying to create an integer from a string, which is technically possible, but only if the string is from a number format. So only something that looks like, if we have a string that looks like this, only then we'll be able to create an integer from it. If there are some characters in there, then we're going to get an error. I hope that was not too fast. Which are correct arithmetical operations? And let's see. Yep. So new question in the chat again. I shouldn't forget that YouTube has a 20 seconds delay on the Discord, so I'll always wait a little bit longer. So A is being suggested the most, C and D after that, and also quite some people on voting on B. So basically, we've never done it because it's not possible, but usually when we assign a value to a variable, it's always from the variable on the left-hand side and the values on the right-hand side. So which are the correct answers in this case? A and D only. Because, and I know it's details and you will notice it if it gets wrong, but this is not possible. In this case, we're trying to assign a value which is the sum of 1 plus 1, so 2. We're going to try to assign the value 2 to the variable 2, and a variable can never be just a number. Doesn't really make sense as well. So if this would be like like trying to compare two values with each other, then there would have to be two equal to signs. So 2 is equal to 1 plus 1. That would be two equal signs here. And we're also not able to assign values to variables in the other way around. So 5 plus 6 assigning to the variable y is also not possible. We'll always have to do it the other way around, just like here. And in case it would make sense for you, it doesn't for me, but it is possible to have a variable named 7 and then assign the result of the operation of 3 times 4 to it. So how does it look? 1 multiplied by 2 assigned to the variable a, print out a, and 7 is the multiplication of 3 by 4, and then print out 7, which is 12. And I'm preparing the next question, which is correct variable names. This is actually something which we didn't really discuss last week. But just out of curiosity, let's see if you have an idea of what is possible and what is not. So which are correct variable names? We want to assign a value of, let's say, 5 to a variable, and we're choosing one of the 4 options, which is going to work and which is going to give an error. A and D. Yes. And some people vote on B and C. So indeed, A and D are definitely correct. B looks something like it could be correct, but it's not. And C is technically correct, but it's a no-go. You should never do that. And why, I will explain it in a second. So why are A and D correct? Well, variables can have, they could look like this, just characters, but they can also contain numbers. In this case, numbers at the end of the variable name, for example, so this is possible. We can also have underscores in it, and we can also have capital letters in there. And remember that Python is capital sensitive, which means that if you have results with a small letter r and a result with a capital letter R, those are going to be two different variable names. So that's very important. The second option, it's not being discussed here after. The second option is something which we call methods. So we're trying to assign apply a method on, or call a method on this variable my, for example. No, I shouldn't discuss it in this way. There can never be a dot inside a variable name. Let's just say it like this. So we can have underscores, but no dots. And why is C technically correct? Because we can assign, and I will do it here. Oui. If we would say print is equal to 7, then we can say what's the value of print? It's 7. But why is this dangerous? And it's very important to notice, because we're overwriting the function that print is doing for us, actually. So now we cannot print out anything anymore. So if we're trying to print out hello, we're going to get an error because we assigned a value to that new variable print. And so you'll always have to pay have to pay attention to the fact that there are some built-in Python functions, and print is one of them. Remember that, for example, the length of a string, let's say hello, is also a function built in by Python. So if you would overwrite this, as in len is equal to 8, then also now we cannot use a length function anymore. So this is a very dangerous thing, and you always have to pay attention to this. As soon as it lights up green, you know that it's a Python built-in function. There are actually not that many, but interesting enough, it's you'll recognize them because of the green letters. If you've done it for the whole notebook, it would mean that, well, if you've done it, it would mean that for the whole notebook, you cannot use that function anymore. James has typed in the chat how you can fix it in a Python way. As long as you're working with Jupyter notebooks or Jupyter Lab, you can also restart kernel and clear all outputs. And that would give you a fresh start again. So that would remove all of the variables that you've assigned, and hence also removes the fact that you've maybe tried to assign the value 7 to a variable print. Okay, I hope that makes sense. Usually that is some kind of mistake that happens in the beginning. So it's if something like that happens, don't worry, you can fix it. Next question is, which are correct type conversions? So we've seen how we can, from an integer, create a floating point number, or the other way around. There are a couple of possibilities there, and the question in this case are which are going to be correct conversions. Hmm. 7, 9, 10. So the people voting on C, what's the answer going to be there? Type it in the chat, and in the meantime, I'll discuss the possible answers, which are indeed A and B for sure, and C actually as well. It's only D that's not going to result in a proper conversion. D is not possible because obviously we're trying to first divide 9 by 0, which is not possible. In Dutch we say wie deelt door 0 is een 0. There must be an English relatable saying. If this doesn't result in a proper mathematical conversion, then the conversion to a string format is also not going to work. But the first three options are correct, and here you can see the results. So in the first case, the sum of 7.0 and 0.1 is 7.1, and we're converting that to an integer and assigning to a variable a. print out that variable, and remember that we're going to just remove all of the floating point numbers behind the comma, so we're just keeping the base number there. In the second case, multiplication, and then convert it to a string, so it's just the result of that multiplication in a string format now. You can't really see it, but it is there. And in the third occasion, 2 correct answers in the chat. Indeed, first concatenate the 2 strings together, which is then 770.2, so 770.2, and then convert it to a float. So also here you cannot really see it, but now it's a floating point number. So as James mentions, this is really an exception because you cannot divide by 0, but otherwise it would have been possible if it would have been 1, for example. So which lines are commented? We've seen it a lot, but only very briefly discussed it in the beginning. And actually only next week you will see that. Yeah, I'll discuss it in a second before I mention anything. I'll wait one more second for YouTube. So in many other program, well, the only real correct answer is B in this case. In many other programming languages, you might see something like this, double backslash. So not in Python. Python, the only way of writing comments is by using the hashtag. But you will see that if next week we start writing functions, there is also the possibility of having this. Yeah, you'll have to describe your function, what it's doing, and that's typically done with the 3 double quotation marks. So then it would look like this is also a comment, but that's only valid for functions. But we'll get there. And technically, indeed, James, this is just a string, just like the last one as well. Yeah, and this is how you recognize it, of course. Oof, I'm not going very fast this time. I don't have a I don't have a poll for this one. So if you could count like A, B, C, D, E, F, G, and H, can you tell me for each one which data type it is? So let's give away the first one. A would be integer. The question is, what are the other ones? In the meantime, James, if you're going to your meeting, right?
Yes.
I was just going to check whether your voice comes through on YouTube, but it should be. I can see it in the OBS.
Cool.
So James has created a poll for the data type none, which is the second one. And that's indeed the non-type. Usually people just type something like, okay, D is, I don't know. Oh, we're getting complete answers. Integer. So Sophie, you're almost entirely correct, except for the second one then, int. It's not a string. B non-type, C list, D boolean, E for... So Sylvia, you're correct, as far as here at least. Good guess, Veronica. H, well, all correct except for the last one, but it's not really fair for me because we didn't really discuss it. And now Sylvia is also correct. Non-type. All right. It's not really fair from me to discuss the last one here. It does look like a set, so I do get the confusion, but it's something that we didn't discuss yet, and it's called dictionaries. And we'll, after lunch, discuss how that looks like. But indeed, so the first one, I already gave the solution, is an integer. None is the value for what's called in Python the non-type. On the third location, we have a string. Let me just go to the solution. The third is a string. Fourth is a boolean, a string, a list, of course. Then we have a boolean, then we have a float. Then we have a tuple, recognizable by the rounded brackets, as opposed to the square brackets from lists. We also have a string, and then the dictionary. So just like you have an integer number like this, and a boolean like this, and a floating point like this, the none is a real Python value. It doesn't mean anything, like it's a null type, but the value, if you want to use it, it's written like this, none. And if you're trying to ask from Python which data type it is, it's going to give you a result that looks like this, non-type. So that's how Python internally recognizes it, just like it recognizes an integer as int, and a list like list, and a boolean like bool. So that was one of the questions I had in an email. So that's why you'll always, if you're asked for a data type from Python, this is what you'll get back, non-type. I hope that makes sense. So sets are also made with curly brackets, not to be mistaken with dictionaries. But sets, we didn't discuss it. It's also not really important. And dictionaries are a bit more important, and we'll discuss that after lunch. I think, let's see. Okay, so the question is, what is the result of each operation? There's two more questions. This is the before last one. What is the result of each operation? So we start with the string my fat cat, and followed by the new line operator. Okay, so this is the string my fat cat. And we assign it to the variable s. And so each time we're starting from the same string again. So the first question is, what's the result of this operation? What is the result of this operation is going to be? It's going to be. So we're going to use the split method on the variable s, which contains the string my fat cats. What's going to happen? And while James is gone, I'll keep an eye on the chat if there are any questions. So don't worry. A list containing my fat and cat. The letters separately. Oh, yes, that's I think, Sophie, maybe you should try. I think, if I'm not mistaken, if there were no spaces, that's what would have happened. I'm not entirely sure, but I think so. By default, split is having an argument here, which is a space. And hence, for each space that it finds, it's going to create a break there, let's say. And so it's going to break up this sentence in words, designated to a list indeed, and then each word is an item in that list. So all seem to be correct. Slicing operation, and I'm going to speed up a little bit. So we were starting again with the same string. The T, let's see if that's correct. Here is a special one. So when we start, the minus represents the, let's see if it's correct, T indeed. The minus means that we start from the end of the list. And basically this new line operator is considered to be one character. So we're counting backwards 1, 2, 3, 4, 5, and 6. And then we arrive at the T indeed. Upper is something that we've seen a couple of times last week. Fat cat indeed. Oh, it is correct else, but not 100% actually. We're missing one thing. Oh, and now everyone stops. These are really details, but let's say that, yeah, indeed. So the new line character here, so the operator here, is going to be present in that upper operation as well. I'm not sure. I don't think you call it a backspace. That's no. So what's the result of the strip operation? I usually always, or now I can at least manage to, how do you say it? Split and strip, I always confuse them. Oh yeah. So the YouTube stream is behind. I'm sorry for that. Yes, Giorgio, with that asterisk, I suppose you mean that that new line character is going to be removed. Yes, so indeed, apart from the fact that there should be the quotation marks, indeed, it's strip means that we're going to remove leading and trailing white spaces, which means that if there are any white spaces after cat or before my, we're going to remove them. There is two more operations like strip, and that's called L strip or R strip. And L strip is going to remove white spaces from the left-hand side, and R strip is going to remove white spaces from the right-hand side. So you end up with a string which is clean, which doesn't have any white spaces at the beginning or the end. A slicing operation to check if you're still up to date with Python counting methods. Cat, indeed. So indeed we start counting from 0. We start counting from 0. 1, 2, 3, 4, 5, 6. And then we start at 7. So the C of cat is the first letter that we're slicing out. 7, 8, 9, and then 10. But the last number is never included. So 10 is not included. So we end up with only cat. I will never count correctly in Python, indeed. It's really, it's mind-blowing. It's really annoying. I do know, yeah. But you'll get used to it. That's the only thing I can say. We haven't discussed find, but let's see if you can have a suggestion of what the result could be. A Boolean as an answer or an error or a number? I would agree that 3 would have been also a good answer in Python logic. The end. Oh, it is 3. Terrible. So what Python is going to do, it's going to try to find whether the string fat is in the larger string s. So find the substring fat in the string s, or the variable s at least. And then it's going to return the index number, so 0, 1, 2, and 3. Terrible of me to think that it would have returned true. I'm sorry, you cannot know all of the operations, I guess. Replace. Let's say that we've tried to replace. How to return the word itself. I think if you want to return the word itself, there is no method that you can call on a string which is going to do that. I think for that you would need to slice it out. So you could say from the results of this operation is going to give you the position where that string starts. And then from there, you could say, you could make a slicing operation like this with that number on the first position here, and then the length of that string on, yeah, starting number plus the length of that string, for example. My fat rat with a new line character is indeed correct. So we're replacing the C by an R, and the new line character is going to be still in that string. S dot starts with cat. Also something which we didn't discuss. True, false. So indeed false. Only checking whether it starts with the substring cat, which in this case is not correct. I'm going to pick out 3 things here, and then we can continue with the real Python course. So the first option, we're having a list with 4 numbers in them. What's the result of li.count and in brackets the number 0? Two indeed, so we're trying to count all of the numbers 0. This could as well have been a string. In this case, we're trying to find the occurrences of the numbers 0 in that list. So indeed, the correct answer is 2. And this one, let's discuss this one as well. Append and then the string A. Any idea of what the result is going to be there? Giorgio is the fastest now, scoring high in the scoreboard. So indeed, A is only going to append the character A to that list. Remember that it's technically possible to have different data types in one list. So we have a number, and then a string. So that's technically possible. And then let's have a last. The length of the list is going to be 4. Pop is going to pop out a specific value. By default, it's the last one. And the list is then going to be 2, 0, and 1. Sort is going to sort them in chronological orders. So 0, 0, 1, and 2 should be the result then. And let's see, slice out the number. Well, this is index 2, Python counting. So that means 0, 1, and 2. So the result of that operation is going to be 1. Oh, I'm sorry, I'm going fast now because I think we've spent enough time at the little quiz. Last question is for you. What's the result going to be from this operation, the last operation here? So we're slicing out some values of the list, and the question is which ones is it going to be? And Veronica on point here, 0 and 1 is indeed correct. Mika also now. So what's happening here? We're slicing out all the numbers from 1 up till the last one. So in Python counting 0, 1, so we start slicing from here until the last element, but the last element is never included, so we count back. So we're slicing out 0 and 1. Okay, I hope that kind of makes sense. I think all of this, the information that we covered now in the in the quiz is essential for the rest of the day today? Because these are really the basics, and these are actually the most important stuff that I think there is. Well, yeah, you can always argue of what is most important, but these are the fundamentals, let's say. Let's see. Is there a question that you might have at this point before we get started with a new concept in Python? Or are we all ready to tackle new knowledge? I'll have a question for you then, maybe, in the meanwhile. I did write it out here. Giorgio, go ahead. You can ask your question if you want. In the meantime, I'm posting a question regarding the project exercise that we proposed and whether you did have the time or you didn't have the time to work on it. And you're not hurting our feelings if you didn't do anything about it. It's just to have an idea what the status is. And any other remarks regarding that exercise are always welcome, of course. So Giorgio, from operator import item getter. It was in the solution of ISO 5.2.2. We didn't talk about it. Okay, yeah. So to answer your question, Giorgio, there is a lot of built-in Python libraries and all so built-in from Python itself, but also third parties libraries. So you could technically write your own library of functions and stuff that Python could or should do, and then distribute it to the community. And the community could then do something like import that specific library. What am I talking about? Examples like Pandas, which is very good, which is great for working with tabular data, CSV files, etc. So Pandas is typically being imported as import pandas SPD. So you would have something like this, import pandas SPD, or import, what else is there, NumPy SMP. And this item getter is something that you can import, and I'm not really sure what it exactly does. It's not also really important, I guess. But it allows you to call new functions that are otherwise not by default built into Python. But we will definitely discuss this because it's a very important topic. Actually, only next week. Might mention it here now again, but we'll definitely cover it next week. So what did we see? I'll continue now. Okay. So what did we see last week? Different data types and how we can compare them with each other, how we can transform them into each other. We've seen how we can nicely print out stuff. We've seen how we can, based on specific conditions, do different stuff in our Python code. And we've seen lists and tuples, which contain a collection of values and which is lying at the core, let's say, for the next part which we're going to cover, and that's called loops. So loops are a very important part of programming because they allow us, basically in programming, what we're doing is writing scripts which do the same thing over and over again. Let's say that, and I'm going to try to draw some stuff to make it a bit more realistic, to make it a bit more real life like. And so what could a loop be? As an example, think about when you're hammering a nail into some wood, then you're doing actually a loop over and over again. So let's say that this is a nail and we're having this very beautiful hammer here. Basically, what we're doing when we're hammering a nail into the wall, let's say, we're going to check whether we still see that nail. And if we still see that nail, we're going to swing our hammer again onto that nail. So you could translate it into programming language as a loop. And in the beginning of the loop, we're going to ask ourselves the question, is that nail still visible? And if so, we're going to swing our hammer onto that nail. So let's say that this is the action of swimming that hammer onto the nail. And then we're going back to the beginning of the loop and we're going to check whether that nail is still visible. And if so, we're going to swing our hammer again. And you can see that we're creating a loop here. Until a certain point, when we've smashed the nail into the wall, then we're going to say that it's enough. We're going to break down that loop and we can continue with the rest of the program. So this is something that you could translate into something that's called while loops. Ooh, what happened here? So far my drawing skills. So what we're saying here is, while we still see the nail, swing that hammer. And as long as we still see the nail, we're going to swing that hammer. Still see the nail, swing that hammer. While loops are very powerful, but also very dangerous. And that's why we discussed them at the end of the chapter, and at least a bit less, less elaborately than for loops. And for loops are the other type of loops that we can have. It's the first time I do this, but I thought it would make sense to try it out here. And in order to explain for loops, I'm going to use a different situation. And the situation is the following. Let's say that in the very near future, when the weather is better and I guess Corona numbers are in the decline again, then we can have a family barbecue, let's say. And I mean, we're still not able to do anything we like, so we're having it en petit comité, let's say. So only mom, dad, your brother, or my brother, and my sister, and me are going to be there. And basically, what we have to do now during our barbecue is we have to cook the meat or vegetables on the barbecue. And so if we want to translate it to some Python codes, then we could say something like, for each member, let's say for each family member, we're going to put some meat or veggies on the barbecue. And I hope you can already recognize a bit that we can translate this in a loop. And that would look like this. So we're having a number of people here, and for each one of our family, we're going to put some vegetables or meat on the barbecue. And so if we translate it to Python or to pseudo programming language, then what's going to happen that in the first iteration, so in total we'll run this for loop 5 times. So for each member, we're going to run it once. So in the first iteration, our family member is going to be mom. So for each family member in the first iteration is going to be mom. Very ugly. And then when we arrive here at the actual command, the actual thing that we're going to do, we're going to say, we're going to put some vegetables on the barbecue for mom. And then we're going to the second iteration, and then we've discussed mom. The second time we're doing this iteration, that value is going to be dad. I'm not doing any efforts anymore. So here for dad, we're going to put some meat or veggies on the barbecue. Then we're going to the third iteration, which is then going to be my brother. And then we're going to put some meat or veggies on the barbecue for my brother, and then sister, and then me. I hope you get the point now. And then when as the last time, so element 5 is myself. Now we get back to the beginning of the for loop, and all of the values here, so all of the family members have had their meat or vegetables on the barbecue. Then we break down that loop and we can continue with the rest of the program. So that's, in hopefully a bit more real life example, what's happening if we're using a for loop in programming. Why is it useful? Because one time our family barbecue will be with 5 people, but it could also be with 100 people. And if you have to iterate or do these commands 100 times again and write it out 100 times, it's going to be very cumbersome, let's say. Also, with only minor modifications, you can also add new features to this for loop. So let's say after you've put the meat and veggies on the barbecue, you will still season them. And then by just adding a new command in that loop, we now can reiterate for each family member those commands, or like add this new command to those commands. So that's a bit the idea. And we will also start with discussing for loops. And for this, I'm going to open Jupyter Lab again and close that ugly drawing. At least I hope it makes kind of sense. So how does it look in Python code? What we need is something we can iterate over. So a number of values. And that number of values comes, in the cases that we will discuss, from lists and tuples now. And so we start with a list, in this case, with the characters A, B, C, and D. And we're going to say for each letter in that list, we're going to print out that letter. And then when we're done with that for loop, we're going to print out that the loop has ended. And I'm going to run that, and then we'll discuss it in a bit more detail. So the result looks like this: A, B, C, and D. And then loop has ended. So what do we need to create a for loop? A list or a tuple with a collection of values. This is typically called an iterator, something which we can iterate on. The second thing is we start by using the for keyword, similar to the if and else keywords. But in this case, we're using the for keyword followed by a variable name which doesn't exist in the beginning, followed by the keyword in, and then followed by the variable we're going to iterate over. followed by a colon, not to be forgotten. And then, similar to if, elif, and else statements, all of the code that we need to perform when we're inside the for loop, we're going to write that in indentation. And as soon as we're out of the indentation, so back at the begin, the base level, let's say, we're out of the for loop. Imagine that this print loop has ended, is on the same level of indentation as print each letter, then what would the result be? We would have something like this: A loop has ended, B loop has ended. So in each iteration, we're going to print out that letter and the string loop has ended. So also here, just like if, elif, and else statements, it's very important to keep track of the indentation level. There's a lot of new things here when we for the first time explain it. So basically, when you're inside the for loop, you can still use the list mylist, but usually you're interested in using that new variable, each letter in this case. Okay, we'll see new other examples in a second, so don't worry if you don't get it at this point yet. If we would, and that's what I tried to explain earlier, if we would try to write it down by unrolling the loop, so without using the for loop, we would have to do something that looks like this. Print out each element, so first extract the first element from my list, assign it to the variable each letter, and then print out each letter. Then extract or slice out the second element from the list, and then assign it to the variable each letter, and then print out that letter. And we'll have to do that 4 times. So for each letter in that list. And here you can see that it becomes very cumbersome if you have, for example, 100 elements in a list, or for example, you have a variable number of elements in the list, because you'll have to write it down for each letter separately. And it becomes much easier, of course, if you can write it in something which looks like this. Yeah, so that's a question that we always get. Indeed, each letter in this case is a variable that you create manually. I can write something else. I haven't defined the letter I yet. So now, instead of using the variable each letter, I'm now using the letter I. And we're getting the same result. So it doesn't really matter which variable name you're using here. You'll just have to make sure that you use the same variable name at the end. So each letter is a variable we create even in the loop variant, yes, or is standard Python command. So no, it's not a standard Python thing. It is different in R, right? I think there you have always the letters E or J that you have to use, or you have to predefine them, I guess. I'm sorry. I shouldn't try to compare it with a programming language I barely still know. But let's have another example to make it even more practical. In this case, and I'm going to extract that line first and then show you what's happening here. So we're creating a ranging object with numbers from 0 up till 10, but 10 will not be included. So if we're converting my range object to a list, the result will be numbers from 0 up till 9. And what we're trying to do right now is for each number in that list, we're going to try to multiply it by 2. So we're going to create a for loop, and we're going to say for each element, which we will call my element, in my range, which is this ranging object, we're going to multiply that element by 2 and assign it to a new variable, my result. And then we're going to print out with an f string the result of my element is the variable my element multiplied by 2 and the result after that. So every time that we're going through the for loop, we're assigning a new value to the variable my result, and we're printing out that result in that print statement underneath. So the last time, and that's maybe also interesting to note, is that my result will still exist and it will contain the last value that we assign to it. So if you would break it down, my element in the first iteration will pick up the value 0, and we're going to multiply it by 2, which in this case my result will be 0, and hence the print result will result in my element 0 multiplied by 2 is 0. Second iteration, my element is going to be 1, and we're going to multiply 1 by 2, assign it to the variable my result, and then print out the result of that operation. And then we continue like that. And here, apparently, I'm trying to show you that my range object is still exactly the same. So we didn't change the my range list. We only did some stuff with the elements inside of that list. And then just to mention that we've done all of these operations on lists, it's also possible to do it on tuples. So in this case, we're having the tuple with elements A, B, C, D, E, and F. And we're going to say for each element in my tuple, colon, print out letter my element. Okay, so the first iteration, my element is going to pick up the value A, and we're going to print out letter A. The second iteration, we're going to pick up the element B with my element, and we're going to print out letter B. And we continue until we reach the end of the tuple, and then we break down the for loop. So you recognize always the same structure, right? We start with for, a variable that doesn't exist yet, in something we can iterate over, followed by a colon, and then followed by, in indented code blocks, some commands. And these commands can be as long as you want. And the loop stops as soon as you're giving a command at the base level there. And now we're going to dive a bit deeper. I guess quite some time until we cover the first exercise, and you can discover a bit on yourself. Imagine, so what we've seen now, and now I remember a bit better, R is always going to pick up the index numbers. Whereas in Python, we literally pick up the character itself, the value itself. So imagine that you want to iterate over both the values in that collection as well as the index. Then you either come up with a tricky, with the trick yourself, or you can use a function that's called enumerate. So let's say that we have a tuple with the following elements, and you can see that there are 2 times the character E. And imagine that in your program, you need to know at which occurrence of the letter E you are. So for that, you'll need also the index of each element. And what you could do, and that's described below, but I'll break it down and try to explain it in the meantime. You could create a ranging object that goes over the indices by using the range function on the amount of elements that there are in the tuple. So in this case, there are 5, but we could automate it by using the length function. So the range of the length of that tuple. And let's see what the result is. So range from 0 up till 5 with 5 not included. So 0, 1, 2, 3, and 4. That's what we need to iterate over. So for each tuple in the indices, and then we can say, let's print out each tuple, and let's also print out the operation of my tuple and each tuple. And then you can see that in the first iteration, each tuple is going to be the number 0 from the ranging object, and the second print statement is going to result in the letter E, because we're slicing out number 0 from the tuple called my tuple. So this tuple, of course. In the second iteration, we're picking up the number 1 and we're slicing with number 1 from the tuple itself. And that's basically what's happening in this code. So we're creating the tuple. We're checking how long the tuple is, how many elements there are. So we can use it in a function, in a ranging object, which will recreate the indices actually. We will call it tuple index. That's actually a better word than each tuple. So for each tuple index in that ranging object, and then we're going to slice out that with that tuple index from the tuple and assign it to element my element. And then print out both the element and the tuple index. Why is it called slicing when we are actually including a thing and not excluding it? I always think about it as you're slicing out an element from that tuple or that list. In that way, it makes sense in my head. I don't really know how I could explain it differently. But basically what you're doing is you're not changing the tuple nor the list indeed. So you're just actually extracting it, but the result is still going to be, well, the tuple is still going to be the same. So anyway, it becomes a bit cumbersome if we're trying to solve it in this approach. What Python came up with is the function enumerate. And what enumerate does, it extracts both the index and the value at the same time. And it's going to return that to you in a tuple format. And so the first output, so in the first iteration, if you would iterate over the same tuple that we've been using, the first iteration, it would be the tuple 0 and E. The second iteration, it would be 1 and I. Third is 2 and E, and so forth. And so if you would try to write it down here, my tuple containing the same values again, and then we're going to say for each line, let's say, in, and then call the enumerate function on the tuple, and then print out the result of that line. And you can see the result, actually it's not correct here technically, but anyway, you see how it looks like. It's a tuple, indicated by the rounded brackets at the beginning and the end, and it has two elements. The first one is the index, and the second one is the element, the value itself. And now what you could do is print out line and then you could slice out the first element from that line, which is the tuple actually. So we're slicing out first element from that tuple, which is going to be 0 in the first iteration, and then 1 in the second iteration, 2 in the third iteration, and 4 in the fourth iteration. But we can also use what's called an unpacking approach. And in this approach, we can say that we already know that enumerate is going to give us 2 different outputs, and we can anticipate on this by using also 2 variables when we're initiating the for loop. So in this case, well, in any case, we'll have to separate them by commas, and in this case, we're calling them index and my element. And so now it's very easy to extract both the index and the element from, in this case, the tuple. And then if you're looking at other people's code, you might come across an underscore. An underscore in Python basically means that you're ignoring the output of, well, you're ignoring a specific output. In this case, it's not really clear. You'll see the same in your notebooks, but let's call it index here. So we're going to say for index and ignore the second element in the result of enumerate on my tuple. And then we're going to print out index, and the result is then going to be always just the index. And then there's not much more for me to say. The following block of explanation is basically mentioning that within your for loop, now you're also able to use conditions. Okay, so you can say something like if, in this case, it's a specific number is divisible by my divider. Technically, the remainder of my number divided by my divider is equal to 0, then we'll do something else. So you can call conditions there, you can assign new variables, you can call other functions there, you can do basically anything else within that for loop, which technically also makes sense actually. So I think it's time, yeah, for an exercise before we go into a break. At what time do we usually have a break? 11 or 11:15? 11 should be fine. Huh? Let's say 11 for a break. So let's still discuss or try to solve exercise 6.2.3. So try to solve 6.2.3 if you have time, also 6.2.4. Basically some background information about the exercise. The idea is that you write a program where you print out all of the positive numbers up to 1,000 that can be divided by 13 or 17 or both. And basically all of the rest you can, but you don't have to ignore it. So I don't care how you print out the output, and I don't care how you iterate through the numbers. The idea is just that you write a program where you print out all of the positive numbers from 1,000, or up to 1,000, and divide it by 13 and 17. So you will see also that the further we approach, well, the more exercises there will be as well, but also, yeah, the more we'll have to think about the exercises. So they'll become, I guess, a bit more difficult as we progress. Don't hesitate to ask us any questions because sometimes, yeah, maybe you're stuck at interpreting the question properly rather than, yeah, finding the solution yourself. So you can also send messages to us in private messaging if you don't like to ask it for everyone. Mhm, mhm. Why? It's really nice to see that there is a lot of different approaches from everyone. And it's also nice that you're sharing it actually. So you can see how many different solutions to the problem there are. That's actually quite nice to see. And I think at least I think pretty much all of you have solved it in a way that on second thought I would have solved it too. So to say that in the solutions there is one that's less wishful, let's say, because creating two for loops, yeah, it's maybe a bit of an overkill. It's not a bitch, it's a bit of an overkill. But if we would do it with two for loops, it would allow us to have more flexibility in the little program that we're writing in a way that we can then have maybe more dividers here. So we can test it for more dividers. I will discuss the solution as it's given in the solutions, which uses two for loops, and then after that we can maybe have a break. The people that were not ready with the exercise can then see, based on the answers in the chat or on what I came up with, whether it's understandable or not, and maybe try to fix or finish their solution. So if we want to do it with two for loops, then we would first iterate over each number in the variable that contains all of the numbers. And then we'll have to check whether it is divisible by each divider. So we're going to also iterate over each divider in all of the dividers. So in this case, there are only two, 13 and 17. And then all of the conditions that you have been writing in the chat were correct. So if the number is divisible by that divider, and that's the expression that we would use for that, we would, for example, say print out number is divisible. This makes a bit more sense. But still here, it's not really flexible, and when a number is divisible by two numbers, it's also not being printed out. So we'll have to come up with a smarter solution. The one that we came up with is creating an empty list for each number, and in that list we're going to store all of the dividers, all of the valid dividers. So if that number is divisible by 13 or 17, then we're going to add that number in the valid dividers list. So if number 1 is divisible by 17 is divisible by the divider 17, what we need to do is call that valid dividers empty list and then append that divider to that list. And then we could say print number So what's happening now? Number picks up the first value of the variable numbers, which is 1. We're creating an empty list in which we're going to store all of the dividers for 1. So in the first case, divider is going to be 13. We're going to check if number 1 is divisible by 13. It's not the case, so we're breaking down the for loop here, and we're going back to this for loop. Is number 1 divisible by 17? In the second case here, in the second for loop of the dividers, and then check if 1 is divisible by 17. Also not the case, so we go back to the beginning of the for loop here. And now we're the next number is 2, and we're going to check for the number 2 if it's divisible by 13 and if it's divisible by 17. And then we're going back to the beginning of the loop, and then it's going to be 3 and so on until we come to the number 13. 13 is divisible by 13. So we're going to append that divider into the empty list valid dividers, which then only contains the number 13. And then we're going to print out number whatever is divisible by the valid list that contains all of the dividers. And valid divers, yeah, it's supposed to be valid dividers. And now it doesn't really look nice. So what's happening now, even though valid dividers is empty, it's still being printed out. So what we should do is check if that list is not empty. And if it's not empty, then we should print it out. So if, let's think not, or what we could do is we can check the length. Yeah, and that's what then I do. I'll just copy paste the code in the solutions. So we're going to check how long the new list with valid dividers is. And if there's only one element to it, we're just going to print out that one element. And if there are 2 elements in it, then we can print out each element separately. This is going to work. And that's how you get something like that. It makes sense if we try to assign numbers to variables in the beginning of the program, so that as soon as we start our for loops, we do not have to use any numbers anymore. So try to always use variables for that, because then if you want to change something, if now you want to check the dividers 13 and 20, you don't have to change anything in the code anymore, only in the beginning. So that's kind of a handy thing. And I'll check whether there are other questions. Before we go into a break. Four point 3.1, the even or odd calculator, another condition for checking if the number was inserted was a prime number. So Giorgio, I will come back to your question as it talks about another chapter. Well, I'll reply it during the break. You did ask me that before. Yeah. We'll have a look at it. Okay, so it seems like there are no questions. Let's have a break until 11:25 and then continue with while loops. So we're not making 6.2.4 as an exercise. If you do have, I don't know, the energy, the willpower to solve it, go ahead, and we can discuss with each other the solution if you have any questions regarding that. So after the break, while loop, yeah, and then we'll see. So let's have a break until 11:25. Oh, so I'm really sorry if I'm not saying your name right, Burchuk. All of yeah.
Sorry, go on.
Yeah, so all of the solutions are definitely also in the solutions folder. Oh, okay. So if I go back one level, there is a folder called solutions, and there is a notebook with all of the solutions, so you can always find them there. But I'll also copy paste it in the chat. Burchu. Sorry. Go ahead, James.
I was just going to point that question out to you.
Thanks.
So, Giorgio, that is an extension of the question. I was having problems in defining the condition divisible by 1 in itself. Okay. Well, yeah, that's divisible by 1 in itself. So all numbers are divisible by 1 in themselves. I see you trying to do it by y there. You have no y. Is that what you mean? If only finding primes was that easy, hey?
I'm a bit later than you, James. I'm reading the print statements. Your chosen number was 0. What fun. Last warning. Please insert a number between 1 and 100.
Yeah, okay. So this is this so you're trying to solve multiple problems here. Finding a prime is a different problem from even an odd computation. So let's narrow down what you want to solve. Do you want to find a prime, or do you want to find even or odd?
If you would want to add that to the even or odd calculator, I would say that a for loop would come in handy. And actually, I think exercise 6.2.4 is pretty much to some extent you can also rewrite the code to be an prime number finder.
Oh gee. So yeah, you're okay. So Giorgio, the complexity is coming because you're trying to do 5 different things at once. So try and only do one thing at once. So if we're finding a prime, let's write out finding a prime. Have you covered break and continue yet? Or are we going to? It's wrong. Hold on.
Who's first? Mm. You don't really need a for loop actually for it. Why? Ja, toch wel. Ja.
So Giorgio, the flag is there. So there are other ways to do this, but I'm using Python that you've learnt so far, and the flag is a sentinel to mark whether. So we're trying to prove that my number is not prime. So we're assuming it's prime to begin with. So that's what flag is there to mark our assumption that it's prime. And then we try to prove that it's not prime
Mm.
by going through all of the possible dividers. And it's actually more than we need, but that's what we've done. And trying to find out if any of them can do a whole number division of my number. If they can, we say set flag to false, meaning this number is not prime. Does that make sense? So flag is a bad variable name. I apologize for that. Maybe that was where the confusion was coming from.
Yeah. So I was
Okay. So the final one, the if flag is just to print out at the end. It's not part of the for. So that's why they're not at the same indentation level, because they're not intended to be at the same indentation level. So the for loop runs, and then if flag happens.
So James and Georgia were trying to find a small program to print out prime numbers. Let's see at least one question. Why do you add slicing 0 to valid dividers in the print statement? So then we're talking about this one. So basically what we're creating here, I will try to show you with a bit less numbers, is we're creating a list that contains all of the valid dividers. So if I would here print the list valid dividers, then it would look, well, it would be empty if the number doesn't has any valid dividers. So for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it's going to be an empty list. And then for number 13, the list will have the number 13. And so if we want to extract that number, we can use this approach. So we can slice out the first element of that list, and then we are printing it out in something that looks a bit nicer. You could argue that you do not have to do that, and then just remove it, just print out the list. Also here, if the number is divisible by 2 numbers, we could say something like this. And then what's being printed out, is just the list itself. So it looks less nice. Could argue about that, but you can see the difference. So for loops, super, super, super important in programming, especially also in Python. Another approach is using the while loops. And yeah, without any further comments, let's just discuss how they look like. Basically, they look a bit like if, elif, and else conditions mixed up with a for loop. That's how you could or should see them. Because how are we going to write them? We're going to use the while keyword to initiate them, and then we'll have a condition. So we're going to check something, whether in this case the result, some kind of variable that we will create, is smaller than the number 10. And that is always just like any other while, for, or if, elif statement followed by a colon. So that's the beginning of a while loop. And then what we do within the while loop is calculate something or print something out, whatever it is that you would like to do. So remember the example that I gave, as long as we see a nail in the wall, we'll have to swing our hammer and swing it against the nail and hope that it won't be visible anymore. But as long as it is visible, we'll do that same operation over and over again. So what you typically do is also use a counter within a while loop. And I will discuss it later as well. But let's go over this example first, and I'll already print it out so that maybe makes more sense to understand it. We start by initiating the result variable with the value of 0. And then we're going to say, as long as that result is smaller than 10, we're going to do the following. And the following is add 1 to the result and print that out. So the first time that we're going into this while loop, the result is smaller than 10. So this evaluates to be true. So we're going inside the while loop. And we're going to add 1 to the result. Print out the result, so that's 1. And then we're going back to the beginning of the while loop, and we're checking whether the result, which is now 1, is smaller than 10. And as long as that is true, we're going to do the same code again. Result is then becoming 2. Print it out. And we're going to do that again. Check whether the result is smaller than 10. If it evaluates to be true, we're going to reperform that code. I'm going to do that over and over and over again until we reach, let's say, the number 9. 9 is smaller than 10. And then we're going to add 1 to that result. So now the result is 10. And then we're going to print out result, which is 10. And in this case, you might expect that we're trying to check out, we're trying to do something as long as the result is smaller than 10. But in the results, we get the number 10. That's something that you might not expect. Did someone hear that sound? I heard something, sorry. So you did not expect it maybe, but it is there in the results because we're only calculating the result after we entered the while loop. So it's a tricky thing, and you really need to think about which value the result will have at what iteration, and hence it's also important to definitely check which operation is being printed where, is being put where. As an example, here is an example that where it's going wrong. And in this case, to make it even more clear, what we did is write an expression, a condition that's always going to be true. So we will always be in this while loop as soon as we start it, because true is always going to be true. So as long as true is true, which is true, we're going to increment I by 1. And so actually we're never going to get out of that loop. So as soon as I start hitting the run button here, you will see that there is an asterisk next to that cell. And that was also one of the questions, which means that Python is still trying to perform all of the code within that cell. And because of we are in an eternal while loop, it's never going to stop. So we'll have to, and you've seen maybe that I clicked the stop button, we'll have to manually stop performing that code block here ourselves. And in the background now, Python has assigned a value to the to the variable I, and that indicates how many times Python has reperformed that while loop. So how many times we were in that while loop. And I'm not even going to try to say that number. It's high. 136 million. Okay, it's not that difficult. So as long, and now I come back to that asterisk thing, as long as that asterisk is in front of this cell block, we know that Python is stuck there. So Python is still trying to solve it. If this is the case, now we know it can be 3 different things. The first thing is we're stuck in an eternal while loop, and then we'll have to break it down ourselves. The second possibility is that actually just Jupyter crashed for some reason, And the best thing that you can do then is restart. These things can just happen. And the third thing is, I was going to say something else. It could also be the case that another cell block is still being run, and therefore this one hasn't been started yet. So you could say, if I try to run this one, there will become an asterisk, and now I try to run this cell block here, you'll see that that also has an asterisk. It's just because the first one hasn't finished yet. Just to say again that while loops can be a dangerous thing, and you really need to pay attention. And to go, yeah, to let you find out more of the complexities in while loops, of more of the things that can go wrong, we've inserted 2 blocks of code. And the question to you is, can you find what is going wrong? So in the first example, we're trying to find the sum of all of the numbers between 1 and 10, and with 10 included this time. And the expected sum should be 55. But you will see that something is going wrong, and it's up to you to try to solve it. And a similar thing is, the case for the second example, where we try to concatenate strings together. And for some strange reason, we're trying to do that with a while loop. And we're expecting this to be returned, but it's not going to be the case. And the question is, where is it going wrong?
Where is it going wrong, and can you fix it?
Yeah, definitely. Try to fix it. And then there are actually easier ways of how we can solve those problems. And the question is to you, what are them? So for exercise 6.3.1, then that would be like a built-in function or a method that you can call on a variable, something like that. Who can find the solution on the 2 blocks of code? Someone has a suggestion?
10 internet points up to grabs. Ten internet points for Veronica. And Sophie, you cheated.
No, that's
That's
solution.
the solution for exercise 631. Okay.
Yeah.
Well, in that case, 10 internet points for you too, Sophie.
I'm not. There is still something wrong with Veronica. I'm going to add what she suggests. So indeed, we're not changing the value of I first, so we'll have to change it ourselves.
Ooh, yeah.
But
well
this
done.
is not completely
Sneaky.
correct.
Yasmin, I think you'll find yours loops forever. Two, just have you run Veronica's solution? Because I'm just looking through it and it actually looks right, even though it looks wrong.
It is. I thought yeah, no, it's wrong. I did it the same way as she did it.
Off by one. Okay, I see.
Should I say it or should I wait? Oh, yeah. Yes, yes, Veronica, now we're there, indeed.
Sophie, that is also correct.
Almost correct.
The initialization. Oh, yeah, no, sorry. No, that's, yeah, you're right. Almost correct again.
The most important point is already there, though.
Indeed.
Yeah. That's the making sure that you increment the value of I by one.
No. Sophie's is actually right.
You just did
it
the
looks wrong,
calculation.
but it's right.
Oh. Why is this then correct? Yeah, okay, you changed I.
Because the initialization for I.
Okay. So I'm going to change the upper one, which was wrong, off by one. Is that going to fix it? Also not. And then equal to 10. So you'll see there are also here multiple ways to get the solution. Also, Chayan has a correct solution now. There's multiple solutions to the problem, and there are very subtle differences, actually. It's just something like changing 1 to 0 and or having an equal to sign here. So we're instead of smaller than, we're doing smaller than or equal to. And also the order in which you do the commands is different sometimes.
Giorgio, the idea of this exercise is to see the pitfalls of using while loops. You can use range in the next exercise, 6.3. Whatever it is.
6.3.1, yes. Any ideas on the second block of code? That looks correct indeed. Mm. Also, Chao Yuan is also correct. And let's wait for Sophie. So indeed, if we would just change the 2 by 1, it would already work. But actually, I would agree that Veronica's solution is even a bit nicer because then we're using a check on the list. So the while loop will be different depending on how long the list is. So if we check how long my list is, and then not have smaller than or equal to, but just smaller than, then this will work always, even if my list has other elements in there. Of course, expected is now different, but I hope you get the point. And to give an idea of how you can solve it, and the sun is now shining in my eyes. 1 second. Okay, better. So basically, in the first block of code, what we try to do is just calculate the sum of all of the values from all of the numbers from 1 to 10. So basically, what we should do is make a list of numbers ranging from 1 up till 10. Know that We will have to use 11 because 11 will not be included, and hence the number will be 10. Let me show you. So that's all of the numbers from 1 up till 10. And then we can actually just use the Python built-in sum function, which is going to calculate the sum of all of those values for you. If only you knew, right? Regarding the second block of code, starting from a list of strings, what we can use is the operator, the method, sorry, join. And join will, literally join elements from that list together. And join is not preceded by the lists, but it works on the lists. I don't know, it's poorly explained, but the list should be in between the brackets. And the element that is going to be used to join them together is in front of the join method. So that's a bit of a strange feature. I would have done it differently, but Python decided to do it this way. And so now all of the elements from my list are joined by using a comma, which could also have been an underscore, for example. I am not going to discuss what is being written underneath it. Basically, what it's trying to tell you there is that it is very important to think about which operations come first and which are following after that operation, because that will define the boundary cases. At which instance are you starting your while loop, and at which instance are you stopping the while loop? And I'm not going to mention it here because it will take some time to explain the code. And basically, you've discovered here as well, if you start I by 0 or 1, the result will be different. If you first calculate the sum and then increment I by 1, it's going to be different than if you first increment I by 1 and then followed by calculating the sum. So while loops, as James has mentioned in the chat earlier, if it's possible to write it in a for loop, it's usually safer. And that's also, let's say, the reason that for now we will not discuss these exercises underneath it, because it would be a bit strange to stress the fact that you should avoid using while loops and then ask you to make a lot of exercises on while loops. Instead, as you guys mentioned in the beginning of today, that you didn't really have the time or were able to figure out how the project exercises worked. What I'd like to suggest right now is that we work on them together right now. And together for me means that if you didn't start it yet, have a look at the project exercises. You can find them underneath all of the chapters there. Read it and choose one of them and try to get started with the exercises. I think now is a great time to discover the first steps and see what's going good and what's not going good. And then we are there to help you. So that's a bit the idea. And I would also suggest that we do that until 12:30. And then we'll have a lunch break until 1:30. James, instead of typing, I guess that you want to add something to what I'm saying now.
No.
Does it make sense? Is it less or more clear? So just read a bit on the project exercises. I think tackling these examples is much more interesting than discussing other possibilities of while loops on dividers and stuff like that. I think this is much more interesting. Is it loud when I type, actually?
Not too bad.
Okay. Oh, zip. I totally forgot about zip. Yeah, if for anyone still here, maybe I will still explain the zip function, because that's actually also quite an interesting one, and we will definitely use it further on. Zip allows us to iterate over two variables at the same time. So imagine that you have two strings here designated with, well, assigned with the values A, B, C, D, E, and a string with F, G, H, I, and J. What we can do with the zip function is iterate over both of them at the same time. And then we're going to use something that looks like this for I and J in zip X and Y. So you're zipping both variables together. And then let me just run it. You will see that in the first iteration that there's a counter that indicates how many iterations we're doing. So in the first iteration, the value I is A and the value J is F. And so you will see I, A, and J, F. The second iteration is going to be B and G. Third iteration is going to be C and H. And that allows us to compare elements on the same positions in two different variables. I hope that kind of makes sense. So imagine that it's maybe a bit more interesting, and that's actually the example that we will look at. We have a sequence 1 and we have a sequence 2, and it contains the letters A, G, T, C, G, C, G. So imagine that you want to compare these two sequences with each other and check which letters are the same, for example. Then you could use the zip function, because that allows us to iterate over both sequences at the same time. So you're laying them out next to each other. I'm missing some of the things that are being said in the chat. I'll answer Patty's question first. Can you assign A to F and B to G, etc.? And then we're talking about this A to F and B to G. Okay, I'm not sure if I understand the question correctly. Basically, what you're trying to do is compare the letters. Let's say that I'll elaborate on this example with the sequences. Now you could say if I is equal to J, then we can print out the letters are the same. And else, so in any other occasion, I and J are not equal to each other. So they are different letters. Print out the letters are not the same. And you will see that in the first 3 iterations, the letters are the same. So A, G, T are the same. And then in the 4th iteration, C and G are not the same. So that's what's being printed out then. Tuur, demo of the situation that's going on with the while loops. So I'm scrolling up a little bit.
Autocomplete, please.
Autocomplete. It's not the integers that are not right.
So Giorgio, this is a feature of your editor. In this case, Jupyter Notebooks, not a feature of Python. But could you demo an autocomplete?
Yeah. So usually any interpreter has this nice feature. As soon as you start writing the name of a variable, you can autocomplete it by using a tab. So let's say that we create a new list and we assign it to the variable myList. Then now we can start typing my list, and I'm stopping now with typing. I use the tab and it's auto-completing the rest of the letters because it recognized it. Also, if you start auto-completing or you press your tab too soon and there are multiple possibilities, then in this case, Jupyter will come up with some examples that you might want to use. For example, if you want to print out, you can do it. Tab and then enter for the choice. That's kind of nice if you have a very long variable name that you don't want to type out the whole time is equal to number 10. Then now you can say a very blip and then hit the tab and it auto completes. Also, James will remove all of your internet points if you would do something like this.
Unless you're a Java programmer, in which case it's natural.
Yeah, Patty, I'm not sure if I answered your question. What about in the exercise of sequence 1 and 2 that you just did with zip? What about if one of the sequences has a different number? Yeah. That's a good question of Esperanza. So what if we're using the zip function and one string is longer than the other? You'll see if it will just stop at the... Okay, so let's say that there are 7 elements in this string, so 7 characters. It will only use 7 for iterations. So it will ignore the longest part of that string. I hope that is kind of clear. So you'll see that even though I added 2 new letters to the string, the amount of iterations are still going to be the same because it's just going to ignore the 2 longer letters. Does make more sense if I would do it like this. Yeah, that's more clear. So you'll see that I and J pick up each letter separately until it reaches the end of the shortest occurrence. And then it will ignore all of the rest. And you can do the zip function also for multiple strings. So you can just elaborate on that for 3 or even more variables. In this case, we're having 3 strings and we're going to use the same approach. So I, J, and then now also K in zip X, Y, Z. And that allows us to compare 3 strings with each other now.
I was supposed to be on a lunch break, by the way.
I was thinking about 12:30 and having now the time for the project exercise.
Oh, right, okay.
Yeah. Yeah. So indeed, Esperanza, that's part of indeed, James, that's part of the mutations identifier project exercise. So the question is, how do you retrieve that specific element? I is not equal to J. I don't want to spoil it completely. But also, I don't really think you will get there with only zip, do you? I already forgot how I solved it.
You're answering Esperanza's question too?
Yeah, yeah. I can quickly check and then come back to it. I will not definitely see it later. You should try to find it yourself. No, I didn't do it with zip in the end. It's very tempting to do it, but the problem I was thinking about is how can you now extract where you are. Even you could say that the letters that are different here are C and G. Then you could say you could try to find C. If you can set a counter. That is true. Aha, I have an ID. So this is a trick of how you can extract where you are. I think that's partially a solution to what you're asking, Esperanza. So we're setting a counter to 0 to begin with, and then for each iteration, we're going to increment it by 1. And so that's how we can track how many iterations we're doing, and at which iteration we are at least. And so we will see when we are in the 4th iteration, and this is dangerous thinking here, 1, 2, 3, 4 now. In the 4th iteration, we're extracting letter C and G, and you will see that those are different and hence are printed. It's actually similar. Yeah, it's exactly the same as here below. The answer was right there. And then if you would like to, I think I'm using something like this, an F print statement. And then I say something like the letter I is being transformed to the letter J. That doesn't look really nice. Like this. So and this would indicate for me that the letter C is being mutated to a letter G, for example. So now we have the position in human counting, at least. And the mutation that happened from sequence 1 to sequence 2. At least here and here. Do you have any feedback on the project exercises? Is it going okay? Is it not really clear? Do you want us to go through it together? Any feedback would be nice, I guess. So just to be sorry if I'm being very direct now, if I scared you, sorry. It's not that you have to do both of them. Either one of both is fine. I needed to point that out, yeah, from James, but it is the case though. So you can choose either of them. I think if you try to solve them both, it would a bit too much.
You're also welcome to have a quick look through both of them to see which one
Yeah.
suits your interest the most.
Yeah. Hi everyone. I hope it's working out at least a bit. I'm not immediately planning to go over the solution or parts of the solution. James, maybe we can think about how we can discuss the projects, because there is quite some materials that we still have to cover, and
There's still
I
plenty
guess-
of time for you to work on the projects.
yeah, definitely, also true. Especially the materials for next week are not, they are very important, but not a lot of theory, so it will not be me talking a lot again. Anyway, that being said,
Before
yeah,
you do move on, I would encourage all of you to spend some time during the week,
definitely,
just a little bit of time, and to try and work on the
definitely.
project.
And I was thinking about a similar approach, that I would be back Monday 2 time periods, or maybe other time periods, you can think about it, and there to discuss any of the questions that you might have. That being said, we'll come back with that, and I propose, well, yeah, to have a lunch break, or at least I will find something to eat. I will be back before 1:30, but I suppose that we get started and at 1:30 again. So I'll be back earlier to discuss any questions that you might have in the meantime. So I will write in the chat break until 1:30.
Giorgio, you pasted some code in the chat. Is there a question you have with that?
No, it seems like a valid solution for one of the beginning questions in the mutations identifier problem. Yeah.
Does it look like a good solution to you too?
Yeah. I think I did it the same way. Yes.
Well done, Giorgio.
You earned a lunch break.
You've all learned a lunch break.
Yeah.
Go for it.
Yeah. All right. So I'll be back a bit before 1:30, but we'll start again at 1:30. Hello, hello. Okay. Hi again, everyone. I encourage everyone with good programming jokes to put them in the chat like Paul. So I hope you had a good break. I think by now we've covered half of what we're supposed to be covering, which makes sense if it's halfway day 2 on a 3-day course. But anyway, I think now we all have the fundamentals of Python programming, let's say, and we can dive into more interesting examples. So I think, at least from my point of view, it's getting more interesting now. I think by now I've said already 100 times that if there are any questions, they're always welcome in the chat. So I'm not going to keep on repeating that. So instead, I think we can get started with the next chapter, and the next chapter discusses dictionaries, as we've already mentioned in the beginning in the quiz. They look like this. But to give you a bit more of a background information, so Python has a bunch of built-in data types, and I once had a picture here. I should have prepared that. If you hold on for a second, maybe I can find it still. No. Anyway, it's a picture of an overview of the different data types there are in Python, and basically, let's see. This should work actually. So we've covered in the beginning of day 1 numeric types, integers and floats. If you're a kind of mathematical person, then complex numbers might be interesting as well, but I don't think it really makes sense to cover them in some kind of biotech, life sciences kind of workshop. We also discussed booleans, and we discussed sequence types, lists and tuples, and we also mentioned that strings are some kind of collection of values as well, in a way that a string is actually a combination of characters. What we didn't cover were sets, because they're also some kind of a special thing on its own, and usually also not very interesting. Let's say if you're comparing, imagine that you have 2 lists of genes, let's say, then you could use set to find all of the genes that are equal to each other in both lists. They have some kind of interesting features. I'm not going to discuss it. I'm deviating from the topic actually. So booleans, yeah, we also mentioned that. So the last data type that we want to cover now are dictionaries, because in some way dictionaries, there are also some kind of special data type, but they are useful in some situations, let's say. And that's we're going to discover here together with some examples. So I'll first explain a bit on how the dictionaries are created and how you can use them. Then I will give a practical example of how it's used in BioPython. Maybe you've heard about that before. And then I'll give some complexities, some more things you can do with dictionaries, which are less important but equally interesting to know. So when we talk about collection of values, we've covered strings, lists, and tuples. And dictionary, in a way, is also a collection of values, but in a very specific way, because they combine actually a set of key value pairs. So they allow us to have combinations of values. And basically how you should read it here, this is an example of how a dictionary could look like. Within curly brackets, we're defining a dictionary. And the dictionary is a combination of items which are separated by a comma, just like a list or a tuple is. But the items themselves contain two different items, let's say. The one is a key and the other one is a value. And the key will always be on the left-hand side and the value always on the right-hand side. And they are separated from each other by this colon. So a dictionary is a collection of key value pairs. Yeah. All combined in one dictionary. And as an example here, I've created a dictionary with keys that are 1-letter amino acids and the 3-letter amino acids as values. And so if we want to create our own dictionary, then what we would use is the same approach. So we open the curly brackets, we write the name of the key, followed by a colon, and the accompanied value of that key. A comma to separate the next key value pair from the first one. C as a key, followed by cysteine as a as another amino acid value, but then the 3-letter code. And then the last one is D and aspartic acid. So that's a dictionary. Similar to dictionaries, you might want to extract values from that dictionary. And the way how you can do that is by extracting the value assigned from a key, for example. And when we are slicing dictionaries, what you should do is, instead of using indices, now you're using the name of the key to slice the dictionary. So if you're looking to the value that is the opposite of the key, so the value of the key A, then we're slicing out the key A out of the dictionary. That is one way, so slicing out. The other way is using a method that's called get. And get also accepts, within rounded brackets this time, the key that's from which you want to extract the value. So in the case that you want to extract the value that is given by the key C, then we use this approach. Okay, so you call the dictionary dot get, that's the method, and then followed by the key within rounded brackets. But there is one important difference between the two methods, and this example should make it clear that you should use one over the other. Imagine that you're searching for a specific value from a key, but you're not sure whether the key exists. Okay, so in this case, the key B is not part of the dictionary that we created. And hence, if we're just trying to slice it out, we will get an error, because Python is not able to find that key in our dictionary. Instead, and let me first remove the type. If you're trying to access the key B or the value assigned to key B. With the get methods, we're not getting an error here. However, what we're getting back is a non-type. So imagine that you're in a program and you're trying to access specific keys and elements from a dictionary, and you're not 100% sure whether you will be able to do that. Then it's always better to use the get method, because it allows you to run the program nonetheless, even though there is not a key with a specific value in that dictionary.
Can I add a bit of nuance there?
Yeah, sure.
It's sometimes better to fail fast, meaning if you've unintentionally made a mistake, you want it to error as soon as that mistake happens, so you can see you've made a mistake, rather than getting back a none and having that error happen somewhere else in your program, and it's not always clear where that came from.
Yeah. So yeah, if you're expecting that there should be a B in the dictionary, then it makes sense that you try to slice it out. I agree. But if it could be an A or a B, and you don't want the program to break down, whether it's A or B, something like that, then you could use the second method. It depends on how you think about, how you reason about your program, I guess. Moving on, if that's okay. Once created, you can always add new elements to the dictionary. And the approach that we're going to use for that is the following. We're going to, similar to slicing an element out of a dictionary, you can use the same approach to assign a new value and key and value pair to a dictionary. So imagine the E and glutamine is not glutamate, I guess, is not present in the dictionary. Then we can say the key here after the dictionary is equal to the value after the equal to sign. And then that will be assigned to the dictionary. So that's how we can add a new key value pair. However, have a good look at this dictionary, and more specifically, notice that the key A is accompanied with the value alanine. Because here in the next block of code, we're going to add a key A with the value glutamate to it. Doesn't really make sense, I agree, but let's see what happens. Now we can see that this alanine value has been overwritten with glutamate. And you can see then that there is only one A, so there is no new A key in this dictionary. This means that the keys in a dictionary are unique. So you can only have one exact key in a dictionary, but for the values, it doesn't really matter. So you can have glutamate as a value assigned to the key A, and you have glutamate as a value assigned to the key E. But you can only have one unique key in the dictionary. Okay, so in this case, we have overwritten the key A. And once again, it's very important. Keys are unique and values are not. I mentioned it here as well. So just like strings, lists, and tuples, but in a lesser extent, also dictionaries have different methods, just like the get method that we already shown here above. If we recreate dictionary, that makes more sense. Then we can use the keys method on that dictionary, and let's see what the result is. Basically, it's a list of all of the keys in a dictionary. And we can use that, for example, to iterate over all of the keys in a dictionary. It doesn't really look like a list explicitly. For this, we can use the list function to transform it to a list, how it looks like a list for us. That's similar to the range function, the range object that's being converted to a list. But on the backend side for Python, they will behave the same. The same is valid for a values method. With this values method, we can extract all of the values from a specific dictionary. And then, so I mentioned that you can iterate over all of the elements here. So let's say for each key in my dictionary keys. So that's how you probably would write it at this point. If you want to iterate over all of the keys. However, interestingly enough, you can also use a different approach, and that is by just calling that dictionary. So and then we'll call k, for k in my dictionary, and we're going to print out k, and we'll see that the results are exactly the same. And James has put some technical details in the chat. I was trying to see whether it was important. So this is a way how we can iterate over a dictionary. At least over the keys. Similarly, we could also do it for values. I'm now changing the code, of course. Let's say that for each value in my dictionary.values, and then we're going to print it out. Then this is the result this time. Okay. And there are actually not that many things we can do with dictionaries. Remember, if we want to check all of the things that we can do on a given variable, let's say, in this case, a dictionary, and we scroll all the way down to the not underscored ones. Not a very long list. Get, items, keys, pop, and values are probably the most interesting ones. So we've covered pretty much all of them already. Pop is maybe another one to highlight. With this one, you can remove elements from a dictionary. So this will pop out the key value pair E, and the dictionary will then no longer contain that key value pair. So only calling the key E is enough to remove that key value pair. And then one final note, but there is no final note. That's not really important. Here is a dictionary of all of the key value pairs that are valid or legit amino acids, at least for humans. So you can use that dictionary in the upcoming exercise, so 7.2.1, which you can tackle now. The idea is that we have a amino acid sequence, so a peptide or protein sequence here, and that we want to count all of the occurrences of each amino acid in that sequence by using a dictionary. So you can iterate over am I saying too much? Maybe. Iterate over all of the keys within that dictionary, and then try to count all of the occurrences of a specific key in that sequence. I've said probably too much, but at least it's clear, hopefully, what we mean with the exercise. And there is an extra thing that you can do. You can create a new dictionary that then contains the keys and the counts as values. So the one-letter amino acids as keys and the counts as values. And now I will shut up for a while. Mhm. So if you could thumbs up in the question chat, then we know how far you guys are. 9 thumbs up. Shall I wait a little bit longer? Sequence. For If you don't mind, Giorgio, I will explain it by showing you, because that would make more sense. In this case, you're iterating over each letter in the sequence. And so the first iteration, count will take up the first letter in the sequence, which is S. So count will be S in the first iteration. We're going to do something, but we're not doing something with it. So actually here is nothing really happening. And then we're printing out count, which in the first iteration is actually just the letter S. And then in the second iteration, it will be F, and we're printing out F, and then T. And so we're just printing out each letter, I think. Yeah. But you should iterate over the amino. And then instead of this A, have the count. If we print that out. Then we have the number of counts. Print my sequence, print my dictionary, my keys, print my keys for each key, my keys for occurrence. So Xavier, your solution is coming close to what it's supposed to be. In this case, you're recreating my peptide library at each iteration over and over again. So probably, ideally, that's not what you would like to do. Let's have a look together, maybe. So I will use the example that we also store all of the information in a new dictionary. So let's say that we create, and I'll call it the count dictionary. There's two ways of initializing an empty dictionary. This is another one. Doesn't really make doesn't really matter which one you choose. So we have this dictionary, and basically what we want to do is we want to count all of the amino acids in that sequence. And for this, the moment I was creating this exercise, I was thinking about it in a way that we can use the keys in this dictionary and iterate over each key, and then check within that whole sequence for a given key how many keys there are, how many amino acids of that specific key there are in this sequence. So basically what I'm going to do, I'm going to iterate over each key in that in this dictionary. So for each key, let's say in my dictionary, and I'll make it explicit by using the keys method, and I already will print each key. So now I'm iterating over all of the keys in that dictionary. What I now want to do is I want to use that information because now we can say sequence.count. So with the count method, we're going to count all of the occurrences of a specific letter, for example, in the bigger string sequence. So given an each key, so the first iteration, it will be A, so we're going to count all of the A's in that sequence. Second iteration is going to be C, and we're going to count all of the C's in that sequence. And now we're coming to your error that you had, Eva. AOF, so that's a different one than AOL. Yeah, okay. I always read it faster, so I didn't even notice the difference there was. So
be clear, EOF is end of file. AOL is end of line.
Nice. Okay, so it could as well have been EOL if it were not the ending of it. Anyway, it means something that looks like this error means that there is probably a bracket missing, or a colon might be also something like it, or quotation marks, things like that. So now we found a way to count all of the amino acids in a given sequence. What we now want to do is store them in the new dictionary. So remember that if we want to recreate, or if we want to add new elements to a dictionary, what we have to do is we call that dictionary. We give it a specific key, and we give it a specific value. The value is the amount of times that we count, a specific amino acid, and the amino acid is the one that we extracted from the dictionary here, so that's each key. And now starting from the beginning, we've built up to something that looks like this, and normally, hopefully, should also, if I call that dictionary, contain both the keys and the counts. What I try to do now is like reason in a way about this problem by breaking it down into smaller parts, smaller problems, and try to solve all of the problems separately. It's not really fair because I already know where I have to go, of course, but I hope that kind of makes sense. So now you might ask yourself, so why would we even want to use dictionaries? And that's the reason why I added the following section with a practical example of dictionaries. And before we get started with it, I'd like to show you this NCBI entry, and it contains the sequence of a given plasmid. Imagine that for your research, you need to extract for a bunch of these files some information, and you want to do it with Python, let's say, then you can imagine that this becomes cumbersome, right? If you need to write a program that takes into account all of these spaces and tabs and all of this stuff, it becomes very difficult to extract the information that you want. So instead, there's ways how you can scrape it immediately from here, from NCBI, but if you would download this file, you can download it as a GenBank file. And that's what we did for you already. And there is a specific library, it's called BioPython, and maybe you've heard about it before, which allows us to deal with these specific situations. And it's not really important that you exactly understand what is happening, but I'll try to explain it nonetheless. The more important thing is that at a certain point we'll arrive to the dictionaries and that you can follow along from there. So basically what's being said here, and you'll probably won't be able to run the code. I'll come back to that, how we can fix it. But for now, maybe it doesn't work. Anyway, if you follow along with me, so from the BioPython library is what it says here, import a specific subpart of it, and it's called sequence input output. And that sequence input output has a read function or method, as you will, that can read in a GenBank format, for example. It also can handle FASTQ or FASTA files. In this case, we're using the GenBank format. And then we're going to print out how that looks like. Also, maybe the file is residing in our data folder. It's the first time that we read in a file from the data folder. And it's called nc blah 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 .genbank. So let's have a look in the data folder. So I'm with my mouse here, left top corner. Open the data folder and then find this GenBank file here. I'll open that, and you can see the same information as we've seen on the NCBI website. Okay, so also here, even though we have this GenBank file, it would still be very cumbersome to extract, for example, the title, or maybe from which journal it comes. Voila, so therefore the BioPython library, and if we use a sequence input output read function, then we can read it in as such. And this is how it looks like now. And before we see any of the dictionaries here, you can see that a record has a specific ID, a name, a description, database cross-references, and a number of features, and then all of the features underneath it. But it also has more. You can, for example, also, so if you want to extract the ID, for example, you can call the record followed by the ID, or from that record extract the name or the description. And here we're just printing it out, and you can see that it looks something like this. Imagine that you're interested in having the sequence. I commented it out because it's rather long. So that's how you could extract also the sequence. That being said, there is also another feature that's called annotations. And if I would run this, then you can see the opening of the curly brackets, which already should give an indication of, this might be a dictionary. So open and close dictionary here. And indeed, it's a dictionary. We can see that because of the colon separated key value pairs. This is the first one. This is the second one. This is the third one. And you will see, if you would also read in other GenBank files, that the keys are always the same. So each GenBank file should or usually has a molecule type, topology, accession numbers, sources, organisms, taxonomy. So that's a list of family, class, genus, species, things like that. So here is an example in BioPython if you're thinking about using NCBI data. BioPython is a very useful library for that. Here is an example of how it's used in BioPython. Maybe also to mention that like the reason why we do that, because each entry should have a source or an organism or a taxonomy. So that's always the same. And that allows us to structure the information for a given GenBank file, for example, in an ordered manner. Otherwise, you might have someone else that has taxonomy with a capital T or taxonomies with E-I-E-S, like differently spelled, and then it would become even more cumbersome to extract that kind of information. So that's why we use a key value, the dictionary format here for. Okay, and then we can use our knowledge from dictionaries to extract specific information. Given that this operation gives us a dictionary, we can slice out the organism or the value accompanied with the key organism as such, or all of the accessions. And like this, you can extract information more easily on the go. And so indeed, Esperanza, you're getting an error. Maybe while we're on the topic, I will explain it nonetheless. Because if we have a 3-day course, we now also have the time to already explain it. Most of you have installed. Yeah, I'll start with the Windows explanation first. If you have Anaconda Navigator, so Anaconda is actually also a package manager, which means that it's going to manage all of the packages that you're downloading, and it will make sure that there are no conflicts between the dependencies of the different packages. So right now, how does it do it? It creates different environments, and each environment has, for example, Python installed with it, and it can also have BioPython installed with it. But right now, the environment in which we're doing our calculations, our Python code, it doesn't have BioPython installed yet. So we'll have to do it manually ourselves. And so you can see in my case, if I open Anaconda Navigator, on the left-hand side here, I have a number of different environments. And right now I'm doing my programming in the base, in the root environment. This is the same one as you should have at this point. And on the in the middle section or on the right-hand side, you have a list of all of the packages that are being installed. And you can search for a package that's called BioPython. And for me, it's going to pop up here, but for you, probably not, because it's not installed. Instead, you can, for example, select all. So all of the packages, and then search for BioPython, and then you will find it yourself. So if you want to download it, you can click that button there. And then I think here on the bottom right, there should be an apply button. And then you can click that apply button, and then it will start downloading. That's the way of doing it in Conda. For the people, and James. Yeah. So if you're using a terminal, what you can also do is anaconda.org. But that drags us too far. But anyway, BioPython. Search for a package that's called BioPython in anaconda.org. And you will see in this case, for example, it's part of the Conda Forge channel. In this case, it's called. And if you want to install it from the terminal, you'll have to do this: conda install -c conda forge biopython. And then I thought James was already mentioning it here. Nope. So that would be the command in the conda logic. What you could also do is pip install. And pip install, so then we'd come here, say pip install biopython. Let's see if it works just like this. So for me, it's saying that it's already installed. So I think this should be the command. As far as I know, pip is not going to take... yeah, it will be overarching over the different libraries, if I'm not wrong. Over the different environments, if I'm not wrong. So this means that biopython will be installed not in a given environment, but over all the environments. Yeah. Are you 100% sure about that, James? Okay. It's good to have a notion of pip, conda, anaconda, package manager, environment managers, but indeed, maybe at this point, it's not the most important. All right. That being said, there is one more thing that we can say about dictionaries, and so basically what we've seen here is that, for example, for the accessions, we're having a list as a value. Okay, there is only one element in this list, but at least a list is a possibility of having as a value for a key value pair. That being said, values can have any type of data type, but the keys not. The keys are kind of strict in a way that you can only give immutable data types as a key. So a string is one, a string is one, a tuple is one. I'm thinking that's it. It's also very specific. It's also something which you won't really bother doing a lot, but at least it's decently interesting to know. So in this case, we're creating a triplicate experiment. And for the first experiment, we're having a dictionary with the following key value pairs. We're having a name of the experiment with a given pH value, temperature, a given volume, calibration, and the date of when the experiment happened. And so all of this information is stored in a first dictionary. And now, given that there are two dates, we can also say that the key instead is a tuple that contains two dates. So we can do something that looks like this, and in this case we're adding a key value pair with the tuple date 1 and date 2, and the list with the same key dates as a value. So you can have tuples as keys, but you cannot have something like a list or an integer there. Actually, I'm not sure about that, but it, yeah, doesn't really matter either. And then to make it even more complex, it's also possible to have a nested dictionary. So in this case, we're creating the two other triplicate experiments. And then we're going to create a new dictionary, and that new dictionary has a dictionary as a value, and experiment 1 as a key, experiment 2 as a key, triplicate experiment 2 as a dictionary, as a value, and so on. And so how does it look a bit complex like this? Yeah, I can't open it even further, apparently. So experiment 1 as a key, followed by a new dictionary as a value. And that dictionary on its own has specific key value pairs. Same for experiment 2. That's the key here. And the value is another dictionary, which contains on its own different key value pairs. That's also a bit the same as you have like, you can have a list within a list and stuff like that. I'm checking the questions. It seems like James answered Giorgio's question. Yeah. It depends on how the program is written. Are JSON file libraries? I'm asking it because some bioinformatics websites only give the option to download JSON files. So are JSON files libraries? No. But I actually never extracted information from JSON files, but I'm 100% sure there must be a library that can do it for you. That like structures your information in a JSON file in some way that it makes it easy to parse with Python. We can, yeah, we can definitely go through it. Yeah. I'm thinking now whether it's worth it to have a break already, or maybe I'll introduce the next chapter and then we can have a break after that. Have a moment to go through the review questions. I will start the next chapter in 2 minutes, let's say. And I'll keep an eye on the chat if there are any questions. So even a built-in JSON extracting library. Nice. You install BioPython, and then I still cannot find it in Anaconda. Why is this, please? So is BioPython working? Can you perform the code that's given there? So pip is something else than Anaconda. So I usually try to avoid installing npip and Anaconda to each other. That only asks for problems in my opinion, because it's not really easy to, I don't know, see which installation came from where. So I would imagine that Anaconda is not able to, and it makes sense actually, to designate whether PyOPython is installed if you installed it via pip. Okay, so it's running. If you're a hardcore Python programmer, you probably want to do everything with pip and virtual environments. That's one way. I'm used to the Conda logic, so I usually try to install everything in a Conda environment, and then from there, yeah, run specific code that is part of a specific project in a specific environment. But that's all, I don't know, none of your concerns in the beginning, I would say. We did not go over the solution of exercise 7211. Usually I never go over the extra exercises, but I think we're here actually already kind of close. Yeah. No. I can discuss it during the break, maybe. I'll just wait one more second and see what Georgia says, and then we can move on. All right, after discovering dictionaries, now it's time to get started with the real interesting stuff. I guess you're all here to learn about Python, but more specifically, maybe you want to analyze some data that you have. And if you want to analyze data, most likely it would come from a file. And hence it makes sense that we also know how we can read in a file, how we can extract relevant information from that, and then, yeah, maybe. Hello? This is James talking to his kids. So either you're fine with having the data there, or you might want to make a plot from it, or, and that's what we also discuss here, you might want to write it out to a new file. So that's what we will discover here. And there are a couple of things that are important when we talk about reading in files. If you search on the internet, you will see that there are plenty of ways how you can do that. We will here explain the native Python, like the built-in Python way, and we will do it in who are we to say best practices, but in better practices. And for this, one long line for just creating a link to a file, we have to do different things. The first thing is create a link to a file, and only then we can read in data from the file itself. And in order to create a link to the file and open that file, so to say, before we can read it in, we'll have to use this line of code. Usually, this link to a file is what's called a file handle, and that's also written here. So what we're going to do is we're going to open a file. So in this case, we're opening the readfile.txt, which resides in the folder data. So we're going to open that file as, and we will name it file handle. So every time that we want to do something with the file now, we will relate to that file by using that file handle variable name. Also, this one is a name that we've came up ourselves with. So it could be fh, it could be hello, it could be anything you like. It just makes sense if you call it, for example, file handle, because that's what it is. And usually when you talk about opening files with file handles, after you open that file and you read in the data from that file, you'll also have to close that file afterwards. Now, there is a way how we can, so you'll always have to think about that unless you use this with keywords. So what's happening here is we're creating an, how is it called? A context. So we're creating a frame. Syntax manager. We're creating a syntax manager, a frame in which we're going to open a link to a file, so a file handle from, and in this frame we can read in the data from that file. That's a lot of blah blah. Just before we get started, makes more sense if we actually read in the data now. It's just interesting to know what's happening on in the background by Python. So after we open a file, now we're able to read in data from that file, and there are three different ways of how we can do that. We can use the read line method, we can use read lines, and we can use read. And we will explore each three of these differences separately by just doing it. So before I get started, I'll open the data folder and I will open how it's called readfile.txt. And you can see that it contains 3 lines. It contains a first line. Here is a second one, and there is also a third line. I'll move it here to the side. Voilà. Now we can see how it looks like. If we would use read, what do we have to do to read in data from that file with that method? We create a context manager with, and then we open that file and name it as a file handle. So now we can read data in from that file handle. So with open this specific file as file handle, colon also, use file handle.read to read in data from that file. And now if we run, if we inspect data, that's better. If we inspect data, what we will see is one long string that contains the complete content of that file. That's one way. If I were to print it out by using the print function, what's going to be different, this new line character here is going to be interpreted, and yeah, so the second line will be printed out on a second line, on a new line, literally. So it will look a bit different, but the string as such is still the same. Another way what we can do is read line methods. And with read line, we're literally reading in one line. So by just calling it over and over again, what we will do is reading in that file line by line. So we're opening that file, renaming it as a file handle. And now we will read in the first line by using the read line method on that file handle. And we store it to the variable line1. And the second time that we call that read line method on the file handle, we will see that the second line will be stored to the variable line2. And apparently what's also happening is there is some white space. Yeah, it's this white space in front of line 2 that is being printed out here. Anyway, it should be, yeah, the thing that is the more important thing to notice here is that each line is printed out one by one. Okay, third method. Yeah, third method is read lines. And read lines is going to read in all of the lines and store them in a long list with all that contains all of the lines separately. Makes more sense if I show you. So here the same is valid, and now hopefully after the third time it starts to make more sense. I agree that the first time you see it, it's one, difficult to explain, but also difficult to understand. But basically it contains always the same things. With open the name of the file as file handle, and then you can call that file handle together with one of the three options that you have, read, read line, or read lines in this case, and store that information into a variable. In this case, all lines is a list. Okay, it's a list and it contains 3 elements, 3 strings, and the first string is the first line, second string is the second line, and the third string is the third line. Why would you choose one method over the other? Well, imagine that you have a long text, maybe a long sequence stored in a FASTA sequence, for example, and you're searching for a subsequence in that longer sequence, then it would be interesting to read in the whole FASTA sequence at once with the read method, because you're searching for an occurrence of a substring within that longer string, and you need to have like one long string in which you can search, or at least that would be easier. Imagine that you have data in some kind of tabular format, let's say, and it's a very, very, very long file, then it doesn't make sense to store all of the information in one variable, because then yeah, your computer, your Python will just be over flooded with the amount of memory it needs to store into one variable. And hence it either crashes or yeah, it might crash, let's say that, or it becomes very slow. Instead, if you need to extract information from a very big file, it's better that you iterate over it line by line and extract the information from a specific line, do something with it that you would like to do, and then export it to a new file, for example. That's what's being given here as examples as well. I don't know how much longer I can go. Maybe it's time to have a break. No. What we will discuss after the break is for a given use case, for a given PDB file, for example, we're going to read in the data, extract information from it, just to show you how it could look like. And then we can have some exercises after that. Let it sink in for a while. Maybe it's okay to have a break until 3:15. Yeah. I'll be around, or I'll try to be around if you have any questions. And if you want to get started with examples, you can have a look at the project exercises or something like that. But for now, break. Hello again. $3:15. So a bit of a longer break. I think that was not a bad idea. In the case of Eva, I hope it will work now. Maybe to highlight for everyone, because it could be a problem as well. So I'm going back one level. So I'm in the, let's call it the home folder of our Python notebooks. And so all of the notebooks that we are running are in this folder, right? And so if we're trying to open a file from the notebook that's called 08 files, and you're using a link to a file, it means that Python starts searching from the folder that we're running the notebook from. Okay, so we're running the notebook from this folder, which means that if you're now referring to a file data/readfile.txt, it's first going to search in the folder data, and there should be a file named readfile.txt. Imagine that I would try to run the notebook from documents, and then there would be this link to a file data/readfile.txt. So now it would search from here for a folder called data, which is not there, and so it's not going to work. So yeah, it's possible that it's going wrong there. And so yeah, to further elaborate on that before we get started with the use case, what James is proposing is importing a library that's called OS, operating system, it stands for, I believe. And then you have a get current working directory, for example. Then you can check where you're running the notebook from. So what the current working directory is, or with other words, which folder you're running the notebook from at the moment. And so this should, yeah, at least the ending should be the same, depending on how you've called it, of course. The ending should look similar. And that means that you're running it within that folder, and from that folder, it's going to search for a folder that's called data and then readfile.txt. I'm waiting a second to check whether it would work for Eva or not before we continue. So, yeah. Okay. I guess James will try to solve the problem, help Eva out, and then we can at least continue. Okay. So, use case. We're having a PDB file. Yeah, that looks good, Xavier. So as long as you're running from that current working directory, it means that you should be able to find the data folder, which contains all of the data files that we will use. For example, also now, the test file.pdb is in the data folder, and I'm going to open it. Voila, here it is. No. testfile.pdb. Small difference, but big difference. And so this is a PDB data file. What should I say about it? It contains some header information. Yeah, a date, some title, title underneath it, immune system, a header information. Some kind of remark might be there, and the sequence of the residue, I guess it's called. So the sequence from the peptide, which is part in the PDB file. Oh, PDB file is a protein, is a file that contains data from a protein, so a peptide sequence. And the sequence itself is given in this secres line. And in this case, it only contains 5 amino acids. It has different models, possibilities, model 1, model 2, and model 3. I'm not sure if there is a fourth. No, 3 model types. And then each model represents the structure of how the peptide or protein might look like. Okay, so we have the 5 sequences given here, the 5 amino acids given here. So the aspartic acid sequence amino acid is built up the following atoms: an N, nitrogen atom, carbon, oxygen, etc., with specific X, Y, and Z coordinates. The A represents the chain. This is some other chemical structure bounding kind of information, I guess. And then the number of that atom. Okay, so basically some information about all of the atoms that make up for a peptide or a protein sequence. And by means of an example, and let me check that I'm 100% sure, we're going to count all of the carbon elements that are in this file. Okay, so we will have to read in the data. And we can, it's not so big, the file. What is it? 260 lines. That's quite all right. It's not too bad. We're going to read it in either line by line or all lines at once. And then we can iterate over each line and clean up the data inside that line and then check whether, yeah, somewhere at the ending we find a carbon element. So that's the idea, what we're going to do. And now we can get started with the code itself. The first thing that we'll need to do is read in the data. So the same first line always is given here. The same first line is applicable always. So we open that file. It resides in the data folder and is called testfile.pdb. And we're going to open it as a file handle. And then we're using read lines method to read in all of the lines at once and store them in a variable called lines. And this would be a question to you, how we can extract the first line of that file now. But I guess I've already said too much, that the question is a bit too easy there, therefore. Sometimes I talk just too much. So if we would have a look at how the lines would look like, this is what it is. It's a list of strings, and each string in that list, so each element in that list is a string, and that string represents one line of that file. So extracting the first line, for example, would be slicing out the first element of that list, and if we would do that, we would get such a line, such a string actually. We can check how many lines there are in that file. by calling the length function on that variable. And there are apparently 263 lines. Is that what we said? The 64th one will not be considered here probably because it's empty. Okay, so that's good. So far, so good. Okay, and then what we want to do is extract the carbon elements from that file. Now, as you can see, we cannot just extract C from a line, from a string, because the C can also appear here somewhere in the middle or anywhere else, actually. So we're going to use the strip and split methods to divide all of the information in separate columns, so to say. And then we can iterate over all of the columns or extract, for example, the last column and check whether there is a C in that column. So as an example, before we start iterating over all of the lines, let's just pick out one line, and we're suggesting the 10th one, which is going to be number 11 then in Python counting. Is that correct? No, 9 then? So line is lines. It doesn't really matter. Let's just extract the 10th one. And we store that information in the variable line. And we're printing out that line. And then we're going to use the strip method to first remove all of the white spaces. You can see that there is still, let me do it this way. So you can see there is still a lot of white spaces here afterwards. We want to get rid of that. So what we're going to do is strip them off. Then we have no more white spaces at the beginning nor at the end. But we want all of the information in separate columns, so we can use the split method. And now we have all of the information separated in, yeah, we could call it columns. Not technically correct, but they are stored in a list. And we know that the last column contains the atom elements. And so we can extract the last element from this new list by slicing it out. So imagine that this is the columns. Then we could say columns last element. And in this case, we have a carbon element. Imagine that we would have let's see, yeah. The one before that would be an oxygen element. So let's see. That would be 9. No. Ah, 8. Oh my. I was off by 2. Yeah, not good from me. But you get the point, I guess. And it's always good to keep track of where you are. Voilà. So now we know this methodology of reading in and parsing data from a file. In this case, applied to one line, we can iterate over all of the lines. So we're going to build a loop that iterates over all of the lines. So for each line in the variable lines that contain all of the lines in the file, what we could do is strip all of the white spaces from it and then print out that line. Nothing big happening here, but we're just iterating over each line and removing the white spaces. As you can see now, if I try to like, yeah, you'll see that it stops here, whereas earlier it would continue a bit further. So all of the trailing white spaces have been removed now. And now actually it's just a matter of combining all of the information that we gathered in one block of code, which does it all for us. So again, we open the file as a file handle and read in all of the lines and store it in the variable lines. We will set a line counter, so each iteration we're doing, so for each time we're iterating over a new line, we're going to increment this counter with 1, just to keep track of where we are. No, it's the carbon counter. Yeah, okay. So for each carbon element that we're going to retrieve, we're going to increment that number with 1. Sorry. So for each line in that variable that contains all of the lines from the file, we're going to extract the information and assign it into different columns like we did before, so strip and split. And then we're going to check whether or not the last element from that line is equal to a C. And if that is the case, we know that we're talking about a carbon element. If this is the case, so if we're talking about a carbon element, apparently what we will do is also we will print out that line. And we will increment the line count by 1. Now, I will first remove this because we haven't seen that before. So what we get back now is all of the lines that contain a carbon element in that file. Apparently it works. Of course it works because we've checked it before. And we obtained 75 counts of carbon elements. And hopefully that would be the same for you. Now you can see that how to say when we're printing out a line, basically at the end here of this line there is still a new line character. That's because of how we're printing it out here. We can omit this behavior by giving the print function another argument, which is called the end argument, and by default it is something like this, so the new line character. Instead we're just going to give it an empty string, and now it just looks a bit nicer. There's nothing much more to it. Imagine there is a caveat with this methodology, let's say, if there would be a carbon element here at the end of one of the other lines. So there could be another check. Like we only want to count a carbon element if also the line starts with this atom column, right? Because if it would be the title, then we're counting a carbon element in that title, but it's not, it doesn't really make sense. So you could also extend this condition here if columns 0 is equal to atom and the last column is equal to carbon, then we will print out the line and we will count 1 to the counter. The result will still be the same, but now we're 100% sure that there's only 75 carbon elements in total in our file. Okay, let's see an exercise now. There is a FASTA file, also in the data folder. Looks like this. And the question is, I think most of you have already solved that exercise in the mutations project exercise. If not, this would be then the first time. The idea is that you read in the data from that file and assign make a variable with the title and a variable with the sequence. And you may have to make sure that the new line characters are also being removed. If you're done, you can also have a look at the extra exercise there. And once again, if you're done with it, then you can thumbs up and then we know we can move on. So, uh, if I you should check whether the notebook from which you're running the code, if you didn't look at James's solution first, that notebook should be in the right folder. What you could also do is when you try to read in the data, just type the name of the file, because you don't have to move to the data folder anymore to find the file over there, because you are already there. So then it should work as well. It's still on. Yeah. So Eva, you're sure that you're opening a notebook here in this folder? So when I'm here in, for me, documents, gentle hands-on Python, January 2021. For you, it's called indeed master. Yeah, indeed, they're new. So you're running notebooks instead of labs, so that's good. And then click on Python 3. Also for you, that would be the same. And then here, if you, it's strange if that doesn't work from here. Okay, so here, let's say, this, that should work. Ah, or what I'd also see now is there are two folders, Gentle Hands-on Python Master. Did you notice that as well? Is it possible that I know that's probably because you unzipped it. Okay, I'm just thinking out loud now. Sorry. Yeah, that's typically Windows. I always have the same thing. Unless you manually cut it out and move it and stuff like that. So I know, James, but we're creating a new notebook now in the folder Gentle Hands-on Python Master. So from there, as long as the data folder is still there, it should work. Yeah, that's a good idea, James. No, is that no? Normally there is. Ah. Okay, that's okay. That's okay. That's okay. Does that work? Nice. Ah, that's super strange. Vanessa, yes. Yes, you can use pandas to read in files. So that is okay. So we are in a gentle hands-on introduction to Python programming workshop. So we need to make choices as to what do we want to cover and what do we not want to cover. And pandas is such a big library that that we usually do not discuss it here. But indeed, it is made to read and extract or parse tabular data files such as CSV, Excel files, things like that. So if you're having such files, it's better to use actually pandas. Everyone has to close their ears for a while. It's better to use pandas than ordinary read lines methods. Or you should actually hear it. I can direct you, but Vanessa, you're also registered for the follow-up course, at least what we call the follow-up course. Sorry, James. So to go on my explanation there, Vanessa, we will definitely cover it there elaborately. So yeah. CSV module. For some reason, I'm just inclined always to grab to pandas because there is, I don't know, such a big community in the data science world that pandas is everywhere on the internet. And so you can also, as real programmers, I have a good joke. As real programmers, we use Google a lot. So yeah. You will find more on pandas, I guess, than CSV module. Is that maybe misinterpreted? How's that joke again? Yeah, there we go. So in case you have a PhD in computer science, so it's not possible or recommended to import CSVs with the ordinary importing methods we just saw. Yeah, technically you can, but I would also suggest that then either CSV module or pandas is easier. It's more a matter of these libraries have a lot of functions pre-installed that you can use to extract data from it and do some calculations with. And so that sometimes makes it more easier than that you try to program it all by yourself. Anyway, we were at an exercise. Maybe it makes sense that we cover it now, that we go through the solution. So for some of you, it might have been easier because it was partially in the project exercise as well. I'm going to make it easy for me and just copy paste the solution. Okay, so it always starts with opening a link to that file. In this case, the data file, the gene.fa, so FASTA file in the data folder. Open it as a file handle, and in this case, yeah, it's still easier to read in the data file line by line. So you can easily extract the first line, which contains the title, and then concatenate all of the following lines in a programming code. So that's what is happening here. This code here is indented, which is not necessarily, which is not really necessary. As soon as we have the information in the lines variable, we can actually go outside of that with context manager. And so we're going to create two different occasions, okay? A FASTA file always starts with, the title of a FASTA file always starts with this larger than symbol, followed by a sequence underneath it. And so we know that if this line starts with this symbol, then we know we're talking about the title. And if that's not the case, then we're talking about a line that contains sequence information, let's say. And so that's what we're doing here. We're going to iterate over all of the lines in that variable that contains all of the lines. And if the line starts with this symbol, we're going to store the information in a new variable. But you'll see that you need to clean it up a little bit if it starts with this symbol. And what we will do, we will remove all of the white spaces at the right-hand side, so rstrip for this. And then we know we still have this kind, we will have still this string, so we also need to slice out all of the elements except for the first one. So from index 1, which in normal human language is the second position, then from the second position all the way up till the end. And that is being stored to the variable sequence ID. And then we can say all of the, any other line will be part of the sequence. And hence we're going to, also here remove the white spaces at the end on each line, and then append it to a variable sequence, which is empty in the beginning, but will then contain all of the lines that are part of the sequence. And that's what we're having then afterwards. And you can see if I would just call the sequence that it's one long string now. So it doesn't contain any new line characters. Whereas if we would forget about that rstrip, let's see what that gives. You can see that there is a new line character in there. And that would be bad if we want to do something with that sequence. Yeah, the next extra exercise, I'm not really going to go over them, but basically what you can see here is that we're going to open a link to a file, similar as what we've done before. And instead of literally reading in that file line by line, what we're going to do is make an iterator that iterates over that file handle, yeah, also in some kind of line-by-line method. So if I would print out line here, then what we get back is each line separately. So this is basically another way of how you can iterate over the file, so line by line, by not using the readline or readlines methodology. And I'm mentioning this because maybe you will see it somewhere if you're Googling some stuff at some point. So just to mention that there are still different possibilities. As a last theory part for today, so I suggest that we have a very brief look at this example here. And then you can make the exercise and we can have some more time for the project exercise. So we've learned now how to read in a file, and now it also makes sense that we want to write out a new file. And actually what we didn't say before is that the open function here actually has two different arguments. The first one is the link to the file, and the second one is a letter which is either R or O or W or X. Now, there is only two cases that's interesting for us right now. By default, it will choose the R letter, and R represents read. So it means that if I would run this code now, except for the error because of these three dots, it would do exactly the same as before. Because of, by default, we're going to use the R argument here. It's different than if I were to choose the W option, which represents the writing argument. So if we want to write out a new file, and in your data folder there is actually already a file with that name, so I'm going to remove it first. Yeah, right. So the writefile.txt is the name of the file that we're going to create. And where are we going to create it? Well, we're also going to create it in the data folder. Okay, so you can see that now for me it's being removed. For you it will be still there, but you will see that it will be overwritten. Anyway, we're going to create a link to that new file which doesn't exist yet, and the link will be rewritten as an F, just an F. Okay, so if we now want to write a line out to that file, we refer to that file by using that F letter here, and then use the write method to write out some string out to that file. And that's how it looks for the first line. And then if we would want to write even more information to that file, then we're just using that write function again, and we can do that over and over again to extend the text that is being written out to that file. So what's also important, that by default Python is just going to write out the next string, so in this case this string, right at the end of the previous string. So actually what it's doing, it's just going to create one long string in that file. And unless you specifically type a new line character there somewhere, it's not going to write out a new line. Okay, so I'm going to run this first, and then you'll see what I mean. Of course, if I print it out, the new line characters are being interpreted. So this is how the write file looks like. And you can see that the first line is now we have a file, and then a new line character has been added here. And then we start the second line, and you can see there is only 2 lines here, even though we're writing out 2 and 3. Yeah, we're having 3 methods here that we're using. Okay, so the B, by the way, is going to be appended right at the end of the previous sentence. And that's basically it. It makes more sense if we have a look at an exercise rather than just look at this silly example. Basically, what else is happening here is that besides writing out data to a file, what we're also doing is opening that file again and then reading it in immediately and completely, and then printing out that text. So by default here actually is written in R, which is basically the same. So yeah, another thing is now, imagine that you want to basically the thing is that you need to pay attention, because even though the file already exists, without any warning, Python is going to overwrite that file if it already exists, and if you're trying to append new data to that file or write out new data to that file. Okay, so if we're now running this code, all of the file will be overwritten, and now only contains this first line. Okay, so that means that you'll need to pay attention with when and how you run the code, because you might as well just remove all of the data from a file. Very dangerous thing. And now I haven't been checking the chat. Okay, no specific questions I see. I suggest that you have a look at the next exercise. Basically, it's pretty much the same as what we've been doing with the test file, the PDB test file. But now, while we're going through that file, while we're parsing out the information, what we also want to do is write out all of the lines that contain valin to a new file. And maybe to give you a hint, you can say something like this with open data test file.pdb as read file open data test file. Something like this will allow you to at once read in a file and also write out a file. So now, while iterating over the lines, you can immediately read in information from a specific file and write it out if it applies to your conditions. to another file. And now I shut up again. Mm-hmm. So the I'm sorry. Giorgio, yes and no. So if you want to extract a sequence, it's not going to work with this code. Hold on, I'm going to read your question again. Would this be good too, or it only works because we have a small file? So this will not give you the same result as you as I expected. What's going on? No. It's I guess it's fine. No, you still have the trailing white spaces here, and does it start with GC? TGC, yeah. Yeah, no, you could maybe remove. Yeah, nee, that's going to remove the last line. What you could do maybe is replace \n. I've never done that. Yeah, seems to be working. So you could come up with a solution with that approach, but indeed this works for rather small files, not if you would parse like hundreds or megabytes of data files. Okay, try to recycle the code from the project. Yeah, but you should. There's no way of reinventing the wheel. I've been using this example so much that in my mind there is only one solution anymore. But indeed, this works, yeah. Clever, clever. From gene ID, I would still extract first character though. That looks a bit better. Oh yeah, sure. Though I will. Let's see. I haven't heard James in a while, so I guess he's maybe looking after his kid. He might he might clean us. He might kill us if he sees something like this. No, I'm my approach is, but I'm Belgian, of course. If it works, it works. I think that's a very Belgian approach in many cases. And I think James, in certain ways, agrees when it comes to writing your own program or code. It's only when you, yeah, it's only when you're, yeah, trying to publish code that needs to do something very efficiently and has to look great because of other people have to watch it and interpret it, that you might have to think about cleaner ways of writing stuff or maybe more efficient or optimal um, programming behaviors. I wouldn't really care actually. If it works, it works.
If I can butt in for a moment,
Yes,
I
please.
think maybe I can offer an alternative point of view. I do care because I agree that when you're writing for other people, you want to be as clear, and that's the important thing. You want to be as clear as possible what your
Yeah.
intentions are, and very often other people is yourself tomorrow or in 2 weeks' time or in a year's time when you're coming back to your script and wondering what the hell you were doing.
Mm-hmm. Yeah. Okay. That's definitely true. For this, documentation lines are a must in a certain way. Now I'm doing this. It doesn't really make sense what I'm writing. But for you, if you're writing your own program, your own script, it makes sense to use as good documentation lines as possible. I would agree on that. I have a very inappropriate joke about it. I will type it in the chat. I don't know if I'm allowed to, but I guess we can still have a good laugh. So always documenting your code. That's the bottom line. Anyway, we were talking about Python, right? How is the exercise going? Did I not even write the name out? Let's have a look at the solution, because basically it's more about the idea of how we can use reading and writing together than finding the exact solution to the problem. Instead, it's I think more interesting to have a look at the project exercise again. So let's see, and I'm going to peek so I'm not writing something silly here. Yeah, I already forgot here SG. So basically we're going to write file. All right. We're going to iterate over all of the lines in the file that we're going to read in, and then also immediately writing out that line if it contains a val in it. Okay, so what we will do immediately is iterate over all of the lines by using for line in. So by using an iterator, and then refer to the read file. Yeah. Okay, so read lines is going to give us a list of all of the lines in that file. And so for each line, we're going to check whether it starts with, not with atom. Because if it starts with atom, then we know that we're searching, that we're on a good line, that we're searching for valin in that line. If line that starts with is going to return a boolean. So if that's true, then we can say we will move on. And then we'll also check if, and this is a bit shorter than what we did before. We're going to check whether there is, in that line, there is a substring that contains valin. So if there is valin in the line, then we'll say I'll print it out, that line. And in the meantime, I will also use write file dot write. So I will write something out to the write file. And more specifically, I will write out that line. And let's see what that gives us. I'm going to make it a bit cleaner again. That gives me something that looks like this. And if we now look at valin file, I've seen that it has been created. It's here. And this is how it looks like. So we've now extracted some information from the PDB file. Have a look at the chapter review if you like. For me, there is nothing more to say. I would like to continue next week and to give you a heads up of what we will cover. We will, James will be happy, discuss functions, the maybe most important part of the whole course. Functions allows us to redo the same code over and over again. So we will cover how to create our own functions and some extra things which we can include in functions. We will learn how to import different modules, so other people's libraries, either built in by Python or by the community. And we will also cover, very briefly, a couple of ones. And then also we'll have a short look at plotting figures. If you're here in the course for a specific reason, let's say I'm having this data and I need to do something with it. Imagine you need to read it in and it's a CSV file. And yeah, you know now that we will not cover it in this course. But you're still interested, please let us know, and then we can see next week we definitely have the time to cover these kind of cases. Imagine that you want to create a specific plot. Let us know, and then we can already prepare something that would be nice, I think. For example, someone once asked us how to create Venn diagrams. So now it's also part of the course, because it's not very trivial to create in Python, or not with Matplotlib at least. That being said, so that's on the program for next week. We'll also work on the project exercise and try to finish that. And for now, it would be nice if you still take the time to work on it. James, well, I will talk for me. I will be here at least until 5. So I can help you if you like. Yep. But otherwise, if you have other occupations or you need to read your emails or something like that, go ahead. You're all free. Is it okay if I close the YouTube stream?
Fine for me.
I'm definitely in the chat for questions. All right. Oh, okay, it's not too late.